Welcome back, everyone. The next session is getting started with research questions. Yesterday, we promised Professor Eric Andriantiana that we would give him a half-an-hour slot to present, but Morto wrote to him, no. So, because we are running out of time, we want to make more progress with engaging with mathematics. Eric is available anytime. For those who are interested in graph theory, what he does, he's available anytime for you to interact with him. You can set a special meeting for that, Zoom, or visit him, or he will visit you. So,
he's extremely friendly person.
Yeah. And the same applies also to all the other lead researchers that you've met yesterday from the focus area. So then we can get on with our plan, which is to look into the two research questions. So we can then split ourselves into two groups. And each group could be working on one of the research questions. Do you think it would be a good idea to stay in the same room, or should we go to a different room?
It's fine. Not that we are shouting on each other. One group can work. One can go and there is.
There is a second seminar room, Kishan, is there? There is an electronic board there.
Yeah.
Well, if we need a board, it's a problem because there's one board. Do you know if anybody is using that room? Could you maybe find out for us?
I'm sure I can check.
Yeah, please. We will just need it from 2 to 4 for now. Then we can use the second room. Okay, so each of you should now decide which group you want to fall in. By the way, let me tell you that this is nothing permanent. This is just, we're just, it's like the board game we played yesterday. This is just for fun, for mathematical fun, okay? So by choosing research question doesn't mean that you're choosing your career path. It just means whatever right now feels most interesting for you, you can pick that one. It's just for us a way to interact with each other more intimately with mathematics. Don't take it too seriously. Does everybody know which group they want to fall in? Okay, so then maybe should we have research question 1 staying in this room? Okay. And research question 2 moving to another room? Yeah.
Yeah.
It's available. Fantastic. So whoever wants to work on research question 2, would you please follow? Are you also in research question 2, Kishan?
I don't mind being in either.
No, but at least you can lead those who want in research question 2. Please follow Kishan. Others can stay.
I wasn't here. See, postdoc is 5 2, right?
So, should we also join the group?
Yeah, so swapping after 1 hour.
No, but you need to.
Maybe somebody can take a picture of this. I'm gonna put it in the group.
I need to explain the problem.
Yes, that's what
Stuck in the definition of the
basic. So then, what? You still have no way.
Also, you can take the picture of the left hand side of the board.
That's right.
Or maybe Kishan can take. Kishan, you take the left hand side.
Take?
Take the left, I'm doing it, not take, I mean.
Oh. Yeah. Then we're gonna go to other.
But you are also welcome to come here and there and
Okay.
we need help on both sides.
Okay. Sure. We can go.
Your friends like. Yeah, maybe you'd like to go there. Okay, so we are not dealing with this, we more or less agreed, right? So, yeah, okay, I shouldn't delete this, maybe I just keep it here and then. Oh, sorry, you need to go.
I will go there a little bit, then I might come back here. There's somebody on the channel.
This can't be online, right?
Change the camera. I'll change the camera. I think it will be still useful if you can maybe use the microphone.
Yeah, but it shouldn't be online because the other group is in another room and they are.
That's fine. One of them can be online.
But it's not a clear idea. And they will miss part of the discussion. Okay, you can hear me, right? I don't need my. Okay, so.
But you can still erase this.
Yeah, I can take it down. Yeah.
Okay, yesterday, we have seen the definition of rings. Do you still remember, or should I recollect it? Very good. So, what is the ring? Ring is a system, it's a R, two binary operations, such that it satisfies few properties. First of all.
Good day. Online, can you
Yes.
kindly zoom up the screen? I can't see anything there. Is any possibility of zooming up the screen? Maybe with the black marker. I can't see anything. Thank you.
You know how to do this?
I can try. I haven't done it before.
I will ask Kishan or Zurab. They
Yeah.
know the people. And we don't have a black marker. No. Yeah, let me follow.
Yeah, please. I don't.
Is it? It's like trying to zoom in a video call. I haven't seen it.
Ah, thank you. Where did you get it? We should pay you, right? Add your commission and then some stamp. 50 and each, right? Good enough? Thank you. Yes, wow. Zurab was pressing some button and then it was getting closer and closer like this. Ah, yes. Yeah, but we shouldn't do more than that, then it will cut, right?
Yeah, At least now you can see.
Maybe is it possible to take out the question and then show the screen only? The question is occupying a space, then the screen is small.
What about now?
Oh, excellent, excellent. Thank you very much.
Okay, so R plus this is a Hegelian group. And you remember what was the group, right? And then number 2 was this is a monoid. In fact, we need 1 there. Or 1 is also not necessary, but if 1 is there, then it forms a monoid. Monoid, you remember exactly what I told and what Professor Janelidze says is the same thing. And then the third condition is that we need to connect these two structures together, and that's why we have this distributive law. So we take any element multiply with element sum and then distribute. And since we didn't assume that this multiplication is commutative, we also have to write the other side because there is no, it does not follow automatically. Okay, so this is ring. Now, if this is not a group, but it is also a monoid, that means you don't have subtraction or inverse does not exist. So you drop one of the axioms, just like a metric space. You drop one of the axioms, you get quasi-metric. You drop another axiom, you get pseudometric. Similarly, if you drop this group condition and if it is only semi-group or a monoid, that means your subtraction is not there. Then that's called semi.
Do you still assume commutativity of?
Yeah, we still assume commutativity. We still assume the commutativity. Sorry. Yeah, this one, when we are saying monoid, we just take the unitary. The 0 is also there. Okay. So what we say that R plus 0, the commutative monoid. And then number 2 is this one, as it is a monoid. For the sake of simplicity, we can also assume it's a commutative monoid. Then it will be a commutative semi-ring. Just to make our calculation simple and nothing else. Then we just write only one of these equations. Okay, so this is what is happening. Now, how to connect this metric space, or rather what I am proposing is this. Let's recall what was the definition of metric space, not without going any kind of discussion. Okay, so metric is a function from two sets to non-negative things such that number 1 was dxy equal to 0 if and only if x equal to y. Number 2, the distance between 2 points are symmetric. And number 3 is did you see I didn't write the first one? Yes. But I wrote it. You see that it is not necessary. Can you guess why? Because my codomain is already this, so I don't need to mention that. So if you mention that, it will be absolutely unnecessary. But if I write like this, then I have to mention it. Okay. But if I restrict my codomain like this and forget it, and then our controversial triangular inequality. D Vatra YZ. Okay, so far you know this. Yeah?
Yes.
Now, what I am proposing, replace your this set and this set by 7. Okay? All these make sense because previously it was just a set. Now I have a set with extra structure, so I'm not losing anything, right? I'm putting more thing. But if I just keep here, then it does not make sense to call this as a semining because semining has extra structure like addition, multiplication. So I must have some axioms related with D and addition and related with D with multiplication. Is it clear why I need more axioms the moment I wanted to involve semining? If it was a set, these three things is fine to define a metric, but I wanted to do metric theory on seminings. So my proposal is as follows. As I said, it's even I myself don't know whether it will work or not, but my feeling is it will work. So take D of X and any element say S, Y is equal to S times this.
Where is S coming from?
This cannot be outside. Let's change it. No, that's not what I want. I want this. S is also coming from S.
From the same.
The same. So X, Y, Z, S, S prime belongs to S. So this equal to this. Okay. And my next proposal is this. Like a invariant. So if you translate, it will not make any change. So these two look after all this extra structure because I have multiplication and addition. My conjecture is, which you need to check now. And if it does not work, we have to twist a little bit this action. My conjecture is, if we take this definition, then this metric actually makes S a topological semining. In the sense, your addition and multiplication will be continuous. Like in nonlinear space, how you check your addition is continuous? You take two sequences, right? D, X, and YN, right? Xn goes to X, Yn goes to X, then you take Xn plus Yn is also go to X plus Y. And that's why you show that addition is continuous, right? Taking that convergent sequences. Similarly, how you check the product is continuous. The scalar multiplication is continuous. Again, you take Xn times Yn. If Xn goes to X, Yn goes to X, then Xn times Yn goes to Xy. So if we can prove these two theorems, these two results for this, using this metric, then this specific metric will prove that this metric actually gives or makes this semining a topological semining. Because to make a topological semining, what you need to do, your addition and multiplication just continuous. Just like a nonlinear space. Because in nonlinear space, what we are doing, we are proving that this function is continuous, and then we are proving this function is continuous. And these two are sufficient just to check the space is nonlinear space, right? That's what you are doing in function basis. So instead of taking this as a scalar, it's come to the same place because it's same S is here. So it will be the product will be continuous and addition will be continuous. Is the question clear?
I think I still need to hear and understand the question. But the elements are from the same set and
No, it's not anymore set, it's semitic.
similarly, then it would I understand why then we would have to put them together, not it like instead of having the Z and the S to maybe a different set, maybe a set of real numbers, X and the five to similarly.
Yes.
So it's just a conjecture because if the S and the Z would be in a like a different set maybe of real numbers. And
No, no, S and Z cannot be in real now.
yeah, they're supposed to be in the same.
I'm just blindly copying your metric theory. Up to here, this is metric space. You can treat this is just a set. But the moment I am saying it's a semi-ring, I have extra structure, addition and multiplication. So I have to incorporate that. Why somehow? And I am proposing this is the way how we incorporate. I am connecting Professor Aphane with myself by including these two axioms. And my claim is, if I include these two axioms along with these standard axioms, that will make my addition and multiplication of my semi-ring continuous. In the same way how you define continuity, addition and scalar multiplication in your function analysis course. Because you have a vector space, right? And then you define a sequence, right? When you define this D, xn, yn, and you show that if xn goes to x, yn goes to x, then if you can show xn plus yn goes to x plus y, then you are done, right? So my question is, you can do the same calculations, and these two should be good enough to get that. So you will prove exactly the same thing. Instead of alpha now, we have y, xy, because both are from the same place. So we show these two functions are continuous, exactly the same way how we have this convergence series. So how you do that? You do like this, right? Xn goes to this, y goes to this, and to show that x plus y is continuous, you just show that from here you can prove xn plus yn actually goes to x plus y using your metric. Nothing else. You don't need nothing else. Similarly, you also show xn yn goes to xy, and then you are done. You start with your function analysis. I'm saying now same will hold. I mean, not xy. In your case, you actually do alpha x. Right. But because in vector space you don't have multiplication unless you being the inner product, then it's a different story. So my question, my conjecture is this 1, 2, 3, 3, 4, 5 will be sufficient to connect metric space with semi-use. Yes.
You defend your axiom number 4
No.
because
Yeah.
like if we put those up, number 5 to me is what is natural because it's like invariance and the translation.
Yes, yes, invariant
But
and
the
translation.
4 is not acceptable because
Or not natural. Yes, yes.
like for example, if we take our real numbers with the usual metric, it's not going to work, right?
Right.
Because 4 doesn't work.
Or doesn't work, yes.
Maybe it's okay that it doesn't work. I'm just saying.
So, okay, let's do this experiment.
Yes.
Let's try to prove and see where it's stuck, and accordingly we can change it, right?
Yeah, yeah.
It can work.
Yeah, but it looks very unnatural,
Yeah.
right? Yeah. But okay, let's see whether with this it will work or not, and then we make it more natural. We change this. So do you like to start working?
So far, I haven't. My idea is for a second or axiom, how to relate the identity matrix with the unary axiom for a ring.
Yes.
Now let's deal with this one first.
No, what is bothering you?
No, just that I want to implement the idea how to manipulate the identity matrix with the unitary ring.
Matrix, where you get matrix?
Metric.
Matrix,
Yeah.
E.
No, and metric, yes.
Yes, and please repeat your question, how to?
How to manipulate the identity matrix with the unitary ring. Unitary ring is the one of identity.
Yes, and you said,
The second condition.
you mean just discussion, what was happening before?
No, I agree. We are trying to implement the idea of relating the metric with the not the ring.
No, there is no ring.
It's semi.
We dropped the condition and we in semi. Of course, we can do the
So
semi.
meaning now there's no unitary ring for
No,
condition.
ring, semi-ring. But it's still unitary in the sense that I can include it or depending whether we need it or not. But we just drop the additive inverse from here to make it a semi-ring. There is no ring anymore. We are more general than ring. We are in semi-ring. So we have two monoid structure and they interact by this distributive property.
Okay, there's a lot of ideas.
Okay, you think, okay. So please write it down and try to use these actions.
Okay, so I just want to try and understand how structure, we are structuring it. So, so now what we're trying to prove that this structure of semi-rings within the distance, within the metric, the distance function can be able to satisfy the properties we have.
No, these are not the properties satisfying. I am assuming these are axioms.
Okay.
This is my new metric space on semi-rings. My claim is, if I assume this, I will be able to prove that. So my goal is to take this definition and prove addition and multiplication are continuous. So that is your exercise.
With this.
I have an idea. Can we prove that every metric space, every metric is a semi-ring, but the inverse doesn't hold or vice versa?
Has nothing to do with that.
Yeah.
Metric space is an animal, semi-ring is an animal. They have nothing to do with each other. By this one, I am trying to put them together. As such, they have nothing to do with each other. Like a topological space and groups, they have nothing to do with each other. But if you wanted to put these two together, then how to do that? You make your operations continuous. Then it becomes a topological proof. So I'm trying to use this metric, this new definition of a metric. I shouldn't call it metric because metric stops here.
Yeah.
So this invariant metric, I called it invariant because of this one, just a name, but can be changed. So using this new definition of invariant metric, I wanted to create a topological semi-ring using this invariant metric. Let me think about.
No, I think, like, I didn't see them here, S and S prime there. Two different ones, S and S.
Yeah,
prime.
that can be done.
No, yeah.
Yeah.
I think might be that it doesn't make much sense to consider it for a ring.
Yeah.
Because otherwise you have that
Absolutely.
distance is the
That is
same.
why yesterday I thought that forget about ring, semi-ring is good enough.
But
Because
I think it trivializes for a ring.
Correct, yeah.
because you can always
Subtract
write,
it, yes,
yeah, and so everything has distance 0 probably already.
I think so. The 70 should be the right choice. So if we can prove this, then we can, do you see, Maggie? If we can prove this, then basically we are doing matrix theory on 70s. Because it's not anymore sets, it's a 70. And now we can define norm. Imagine that we managed to prove this is continuous and these things. Then we can define norm on these things by just d of, norm of S is defined as d of S0. And what is d is this d. And then it will become a non-linear 70. Maybe you do not need.
Yeah,
One is sufficient.
I was just saying that I didn't see at first.
Ah, okay,
So
okay,
if you
okay.
as an-
Is it clear what you have to prove, right? You just remember how you prove that thing. The usual thing in function analysis. Try to understand that proof and reprove it for this setup. Because you didn't have to prove those things with these things, right? It was because it was only vector space. So if you need little bit of help, Elena is here, but she is not supposed to prove theorems for you. Okay, it is your exercise. The same case in both places. Yeah, I mean, it already includes SEM, right? Yeah, I'm taking more. If I need to make SEM, I can choose SEM. That's sorry.
Really just same as.
No, I don't know.
Exactly the same as. And then you get to it.
Yeah, so I took more general. But of course, like, we can take case and expand SEM. I mean, there is not.
All some feelings that feelings.
Or we can actually change this one by like this. Any real number R. No, that will not make sense. X time R will not make sense. It's a problem. We can put S in one place also. Not in both places, but then other places is fine. We can take one also. It's not a problem. Yeah, we need to do actual calculations and then we'll see where is the problem and let's change accordingly. Yes.
What if we do like this? For this one,
Sorry?
before that.
You want to compute the distance. You need two fields. Distance between this and that.
Yeah, no, doesn't make sense here. I'm trying to do, because we can do it from, so it doesn't make sense. So,
Just do it. The distance between. Distance, you need two fields. Distance between, is distance between x multiplied by s and y multiplied by s, comma, to separate the two fields. Right?
so meaning, what if I say y1?
Is still one field.
And then I get to use a y2, let's do y2,
I mean, I don't even know what you want to write, but every time you write a distance, you need two fields. That's why.
Yeah, just you take a sequence. You then mix and go away. Condition is xn goes to x, yn goes to x, then xn y goes to x. Yeah.
Like, reference here at least,
Possibly.
because otherwise, try to
But
Yeah.
still I don't get the first example because when I try to use it to prove it using the usual matrix, it's the, okay, it's the, oh, okay.
distance between that.
Yeah.
To distance between this and that and
Right.
this and that.
Right.
But these and these are different, so they're less and less prime, right?
They should be different.
I think.
Yeah. Possibly. I didn't do any calculation, just very raw thought. So we need to be corrected and changed. Ishan, is the question clear? So we replace the set by seminar. And these are the 5 axioms, possible axioms, need to be modified if needed to show that addition and multiplications are continuous.
Okay.
So, yeah, I mean, you show that xn goes to xyn goes to x and yn plus the usual way how we prove the addition and multiplication continuous.
The order is less than equal to is from the group.
Yeah, because no, order is on the other side. It's a positive real, so it's fine.
Sorry?
You mean the last triangular inequality?
Yeah.
But that's
The
that's a
usual
real number. It's not a problem. So I'm
So
changing only the
inequality
domain.
between real
Oh,
numbers.
okay.
I'm only changing the domain.
Okay.
So can we put the restriction that x comes s comes from x and then y s prime comes from y.
What are x and y in your sentence?
Maybe x and y come from the element of x.
But there is no x. What is x? X.
It comes from
X like this.
x.
X. There is no x.
It's similarly.
But-
S.
But so far now we need to put the restriction for s prime and then x s. See that s prime s.
Maybe if you ask what is S and S prime.
Yeah. Those are just 2 elements followed from S&D.
We changed it to s prime.
This.
Yeah,
Yeah, that is.
Because-
You do need that.
if they need that, because if they are different, always I can choose them same. But if I choose them same, I cannot make them different, right? Depending on the calculation, how you need them.
I think to prove this, you need the S and S prime that happens, right?
For the second improvement.
For the second
For the production.
yeah. Also for the sum, but we have already taken that. Yeah.
Oh, sorry. Thank you, Kishan. I mean, at this stage, I don't think even multiplicative identity will be needed because those things may be needed in compactness and those things when you check, but at this moment, only semi-group will be sufficient.
Yeah.
This one should obviously be a morphism if that's where it's in.
What?
So isn't it,
The distance. What?
So it's only the S is the same with the S. S times S.
Yeah. It's just you replace the set with the semi.
Okay. Then S times S is the same either. R is the same way.
Yes.
So S times S to R should be a same map.
No, I didn't say sending homework.
But I'm saying, should we expect it to be?
No,
No.
no. Because I don't think from any one of these it follows it's a sending homework.
Would it? It's like plus.
Yeah, that's a question. Is it, can it be improved from,
It's true.
This.
follows from 5?
No, it's not.
Huh?
It's,
I don't
no,
understand
it's not.
because you adding S and S prime, but on the right hand side you just have X1.
Yeah, it's not intuitive notion of distance, but these properties are not intuitive.
And here you're multiplying and it's invariant.
No, these are not finalized. These are just
Okay.
proposals.
No, but I
But I'm saying, are these proposals coming from some example or is it just?
I think they are coming from the fact that we want to prove
Okay.
they are made so that we can.
Yeah. So
That's it.
this is my speculation for prove that one.
Okay,
But if we stuck, of course, we will modify accordingly so that
Sure.
we can prove that.
okay, I get it now.
But
Uh,
also if you do it for a ring, that is just
Yeah,
really a ring.
You are asking something.
Some distance zero.
Oh,
I think not.
To see if we can generalize those two examples. I know they're just assumptions
Yes.
for now,
Yeah.
and maybe we might need to modify them.
Yes, we have to modify them to prove that. Yes, absolutely. Absolutely.
So I have a problem with using like the four elements. We can maybe start using them to see if probably the same ring those if we have them between the two products or the two additions.
And y minus y.
Yeah.
So it's the same as the distance between 0 and 0.
Yeah.
So it's 0.
So
when you add some-
that's why is equals to dx1.
Yes.
Yes, and then we try to prove how we can make this like as in having the xy. So the xy from my xy is equals to dx. Yes. Y. So we're having this approach. Let me just say. So we have something like a product. So this is.
Transport, so that these are cities, edges, transport routes. Then integrated can use. Right, cross travel from.
But gives you a sense if we take for commutativity. So it will be 0.
Yes,
You might be some other things in.
Right.
that will be zero.
Duration.
By 1.
And the idea is also that.
Yes.
It's also obviously real life, that doesn't see that it's not fixed, so over time.
But good, it's good that you are thinking. That's exactly the purpose. Think.
That's
I
why.
don't know an answer. As I said, it's just an idea.
Yeah.
But let's play with these axioms such that it will fit our goal.
I see.
Maybe you have to change completely the whole thing and we have to rethink some different way. But you got the idea what I wanted to do. So try to prove that continuity and see where you stop. And that may guide you how to modify this. I think that will be a real way, actually, doing mathematics. Because you already don't know what will be our idea, then it's not mathematics. We don't know the end result. So we do experiment, and then we come up with a set of axioms. So metric space didn't come as it is ready product in checkers. People do experiment, and then came up with axioms. Yes.
Another axiom that I can add there.
First of all,
You add the axiom,
For
try to prove that.
first you do some mathematics by hand and see you have a problem and then you fix.
for some proposing a symmetry or a commutative.
Sorry?
They see me.
It's commutative. Let's assume commutative if that helps you. That's not a problem. Take your semi-commutative if that helps you. We assume commutative, yes.
So meaning now we have to create our own theorem.
This is a definition. Let's prove if the definition is correct. If this, before metric space was born, they just took a set and then defined it with a metric D, and then they put properties.
Yeah.
And then from these properties, they checked. Yes.
Okay.
And then they found that for the space to say is a metric, it must fulfill these properties. So this is what we're doing today. Our D now is mapping from S cross S.
You can make.
We are introducing a new D. You've got your set
I see.
with your new D. And then we're adding
I
the
think it's
properties.
one service.
Proof if these properties can be fulfilled. If they can be fulfilled, then we can define a new D. That is what you should be doing.
We are trying to create a new mathematical structure.
Yes, we are trying to create a new notion, but we are starting from a metric. So instead of D mapping from X cross X, it's no longer mapping from X cross X. We are now bringing a new structure. It's mapping from S cross S. Then test all of these properties.
So meaning now there's no set that is contained in both. Say in a and living and making.
It's a very new structure. We have to prove it. Like the same way they proved the metric spaces. That's what we should be doing now.
Spaces. So it's just enriched.
No, but then this will not work. I think.
Yeah, that will solve what you've asked.
Yeah, but
Then it will create a problem there.
it doesn't really solve. Yeah, it does.
It does solve.
But
I mean, then you will learn, no problem. I mean, we need to do the calculation.
The figures.
Is there different? And if they are different, then there is a problem of this action, then it should be similarly. So it's actually.
Oh, yeah. Oh, okay.
But if we want to do matrix, then I have to do this.
The converse.
Very sharp chance.
It'll be mental spaces.
You just enrich in 0, infinity, infinity. Zero. Great. Then composition becomes the
Yeah.
How does it speak when you start meetings?
That's what I'm saying. You need to put less.
I think I have the first one, addition.
Continuity.
We've only using that.
And of course, I didn't use number 4 because for addition, we don't need number 4.
Okay, but we're only using the same S.
Yeah, same as.
Can you show?
Where is this invariant to? Yeah, China invariant. So I just add more and
Does that have any question?
I tried using it for visual the last one.
Try.
The last one.
The additions. Yeah.
Yeah, that question.
So what did you do?
So
Okay, what is your question?
instead of using, I just use some counter example instead. Like use your usual metric to prove that.
What do you mean use the usual? Because usual metric was just. Yeah.
Or we don't know if we can use it there.
Now this is we assuming it's true, and we want to show that these things are used. You understand what that means?
Yeah.
So we're taking this as true. And we're hoping that we can prove this, but if we need, we can change this a little bit if we're getting stuck here. That's what we're trying to do.
Can we use like the same, the SLM to like XS, YS? We have them to be the same, like the S to be the same as the 1S. That's
Yeah.
also right.
Because these two are any real numbers, it's fine if you make them the same, right?
Also on the second.
No, the second one now we are saying that it's the same.
It's the same S. Okay.
Yeah, it's just a proposal, I mean, feel
But-
free.
But this, our aim is to prove this, if we need to change this a bit, no problem, as long as we can prove these things.
Because I mean, we have these are the same waves.
Let's check
No, we're
different.
not showing
That
this.
can make it.
This is we taking this.
Like that.
We want to prove this. Xn converges to X, Yn converges to Y, then Xn plus Y converges to
Yes.
Ah,
You get that?
why? So it's equal.
Yeah.
No,
it's not X and Y, because X and Y are the same.
yeah, this is
But
not.
X and X
Why?
is equal to X and that's
Wait.
equal, is X and X. Or Y.
Yeah. But it's true.
It's true, but it's very weird.
Very weird, but it's true. Maggie,
Did you get it?
it's true.
Okay. Let's see.
So this is addition.
Yes.
No, S is this, yn, S prime is y. We keep two different S and S prime in the number form.
Okay,
No, number four.
number 4.
So our S is yn and S prime is y. And according to number 4, we can kill them and leave this, but this is by hypothesis of done.
You don't
It's
see.
done like
I
this.
see.
Thank you very much. You have the lead now.
Yeah. So we call it Aphane matrix.
Person.
Yeah, I was checking one time, we did ask some questions that can be.
Now we have that. The
Yeah,
distance between
yeah, but I didn't see the.
and if it
I
has
would
zero,
just a question.
is
I also searched.
Yeah,
I didn't find any this kind of combination.
So this would become 0.
yeah.
And
And
this
here
would
I
be
can
one.
put anything.
Yeah, so this would be say still 1.
So distance between 0 and y is 0. It breaks
Why is distance between anything and 0 0? Isn't it?
because I can take.
You
I
can
think
add
to
it,
the
right?
one.
You can add a zero, no, zero and another zero, and then because of maybe
Say-
Elena will write explicitly.
Yeah, I'm saying that. Because.
Okay, how far are you with your calculation? At least these axioms are correct. I have a proof. All of them. I mean, all of them are sufficient to prove those.
Oh,
You don't need
Yeah,
to
yeah.
change anything. Of course, we can make it better, but we don't need, we're
Yeah.
not stuck.
from here, this is true. And y times.
And
minus
Professor
y.
Aphane said my
This is true.
correct.
I don't see them.
Right, Maggie?
We're using this.
it makes sense.
No, I'm just thinking. Why can I write?
Definitely somebody have done this before, right?
Yeah, maybe when we do the investigation,
Oh, this is just dy 0.
maybe.
Yeah, no, it's not.
They,
Yeah.
they give it.
Take the distance between x and.
But Elena, is there any contradiction in my actions?
I'm working. I think this might also break this. Because
If they are different?
yeah. Because 0 is the distance between x and x, and now I can multiply x by 0.
Yeah. Ah, yes, you are right.
Yeah.
So we have to go to pseudometric
At least, yes.
at least. Ah, which is good. You see, nobody thought why pseudometric is better than metric.
No, but.
No, but your argument is right. You can take one of them also.
No, I know my argument, right, but I think a lot of
Maggie, we
things.
call it pseudo or quasi? Which one is close for first one?
But a lot of things are going to be
If we
0.
take only one implication in one, we call it pseudo, right? Or that is quasi.
I'm gonna try break the whole
How
thing.
is this working? The symmetric potential.
Ah, and if we take only half of first,
Break everything. Please break.
probably you have one pseudo.
So it's not.
Kishan, please tell me, why are you laughing?
We want to break everything.
You wanted to destroy me more, please go ahead. Please, no, that's the whole idea, please, break it. Because we are going to construct the theory.
And when, like, if I put like, with 2 random fields, I get the distance is still. So a lot of distance.
Right, so only,
That's the thing, but also it legalizes a lot, like a lot of distance is become 0. Because of
because of number 4.
Because I take x and x, I choose whatever. And multiply x times whatever and
I see.
y times whatever and till 0 is this.
It's not a good place. Makes sense. Makes sense, so How can you
But
make
we
it?
in fact, we are trying to break the triangular inequality. We break that.
That you can't, I'm sure. Try.
Every dxy is less than or equal to 0.
Everything.
Everything is there.
Yeah.
That's too bad. So which one is the problem? This one?
Yeah.
Okay, so, okay, it can be proved, those things, but they make it trivial. So I have to defend myself.
Even. Okay.
You're right.
You make a
Box for me.
Then really science.
What, it does not make sense.
They were like the proof of the first axiom.
We're not proving x here.
We are not proving axioms.
Remember, I said we're taking those things for free, they're true. We wanted to prove if those things xn converges to x, yn converges to y,
Where
then xn plus yn converges to x plus y.
That's right.
You know what convergence is?
Yeah.
So suppose xn is a sequence, it converges to x. Yn is another sequence, it converges to y. Then what happens to
You know, these was
xn plus yn? Where does it converge to?
like, we need much.
We want it to converge to x plus y.
Yes.
I wanted to know if you can quickly help me, but all your stuff is no, it's fine. Exactly.
So if x is a sequence, yn is a sequence, yn is a sequence, then does it converge? We don't know. We want to show it converges. We want to show it converges to x plus y.
Everything.
Get what I'm saying?
Same as.
Yes.
Yeah, I'm saying
Just because we have the.
if xn converges to x, yn converges to y, then we want these things to be true. What does that mean?
Yes.
Like. This is that's the
Right.
we had something similar. I don't know, but something.
Just right, whatever you are thinking, just right.
I don't know what.
Remember convergence? So this is what we want to prove for this first one here, for the addition.
Ah.
I don't know if it works, but.
So do you want to try that now?
Okay,
Because,
say you can replace.
No, I don't know.
Yeah, I know.
I'm saying that.
Doesn't
yeah,
really make sense.
Because.
It doesn't really make sense.
Let's go to the classical. The program. And see how we could.
Yeah.
Instead of.
What does this mean?
Then we see how.
Differentiate function. Our function is defined as a.
Yeah, but it's not n, it's just d.
I was trying to put the continuity.
Yeah. But continuity should be like that, right? So I don't know.
Sorry.
Vector space.
Yeah, it's the.
When epsilon becomes 0, there's
Pretend that this is your scale. And.
Yeah, but
And
now
that's
you
one.
can take it out
Back
of
to
the
it.
distance.
such that for all n, because
So what you
you
are
have this
doing
x
is.
n plus y n,
Yes,
the
It's
distance between x n and y n plus y n x plus y is less than x. For x n converting to x, you'll just
classical.
delete the y n paths and the y path. For the y, so what I'm saying is,
The distance.
Right?
We can use all the modulus.
How it comes up, I'll solve one.
but we don't need to use modulus because we know this is positive or non-negative.
I don't know how it's.
We know this is also positive because we're saying
Then
epsilon is bigger than zero.
and this goes to the, it's all history. But we can't do that.
Do you guys agree? with what I'm saying here for convergence.
I'm saying,
But then,
Yeah.
less than absolute.
Sorry?
Less than absolute.
Yeah, so we want to assume that xn converges to x. What does this mean? It means that
Distance between x and
every epsilon bigger than 0, there exists a natural number n.
yes.
I'm gonna just label it with epsilon. It's a natural number such that
Yes, it is. Cannot.
if n is bigger than this capital N epsilon, then distance between xn and this, what did we want to converge to the x? Less than epsilon. So we can make it as close to epsilon as we want. That's what xn converging to x means. You've done this when you did matrix space. Same thing for y.
Whatever.
You can find a capital N like this for the yn sequence as well.
So we prove them separate.
No, we are taking this to be true. What we want to prove is for xn plus yn, this sequence here, to x plus y, we want this distance to be less than epsilon. But how are we going to do that? This term here, we want to force it to be less than epsilon based on these conditions 1 up to 5. That's what we are trying to do. So you can start with this, and how can we apply this? This is what we need to think now. Which property can I use to simplify this in any way or manipulate it? Makes sense. You give it a try, and then you can ask as well.
Product is a problem, addition is not a problem.
Okay. Yeah, that's D0 X thing.
This is fine. This is the problem. Oh. You managed to prove those two things. Addition and multiplication. Okay, good, try. In a classical case, it's a vector space. So you have alpha xn goes to alpha x, and then you can take alpha outside of your metric. And then it's trivially true. But here, if you have product something inside, I cannot take it outside because it's nonsense.
Yeah.
And that's the problem. I cannot take out S.
Yeah.
Unless I do a absolute cheating. Then probably very cheating. We consider semi-rings which contains, yeah, you are done.
I mean, if we assume that kind of thing,
Yeah,
I think I can prove that it's continuous using 4 with the same S.
unless Kishan will try to try you. But please write it and then let's see whether it will contradict any other things are trivial. Okay.
I mean, I just repeated you here. So the same idea that I introduced is mixed per x, y, and. So now I have this less equal with the product. That thing.
And
then
how you got this equality?
This is 4, but now I have
Product.
I applied twice. Number 4 here with yn.
But number 4 is a problem, right?
No, but it's a problem if S is different from S prime.
Ah,
Because otherwise, because you cannot.
Oh, yeah,
do
yeah, yeah.
zero
Oh,
from
oh,
one
okay,
side.
okay. So if both are yes, then there is no problem.
But you need to have this condition.
Ah, okay, okay, okay.
But it's not, I don't know if that condition makes sense.
If that is
I'm trying to use the usual method.
let's take Pythagoras theorem.
That's how the convergence is defined, right? Any epsilon bigger than zero, there's a natural number such that any n bigger than that natural distance to from x into x is less than x. Okay. Now we want to
Show this, what is it? 16 plus 9, so 25, so this is 5, right?
get true. That's me.
Yes, that's fine.
I'll make sure also yes, yes, times this.
So what is type of this method? It's not a usual method.
Yeah, it's not including. I'm just.
It works for that.
Because in general, we take class here.
Yeah.
And if class is bigger, of course, product will be bigger. Because
What we want.
product is, yeah. that's
want
true.
first-
Bigger is-
But does it follow somehow from the triangle?
I don't think so. I don't think
We
so.
know x can register.
Also, there is no,
See?
yeah, it follows from it.
It does.
It less than equal.
Is it true?
Yes, because the sum is always smaller than the product, right?
No, because if it's
If one of
between
them is
zero
zero.
and one,
Yeah, yeah.
and also if it's between 0 and 1, when I multiply.
It's a
it-
fraction, yeah,
it's-
yeah, so it does not follow, so we have to add. Now, what about these fractions,
X of various x beats. This sum of these things.
right? So imagine, this is one.
If n is bigger than n two epsilon.
And
One, this one, three and two.
No, it's the same. Yeah, I can change it to n.
But if it's 1/3, yeah.
then it would be one, right?
Why? So why? Some do the right side.
Say, if this distance is a fraction, this distance is a fraction, will it be true that always the product of them will be bigger than this?
Yes, and then now
We want to show.
Let's take this is.
I mean, no, we cannot take the usual distance
No,
in
it will not work.
R2
Yeah,
because
yeah.
it doesn't work
It will
anymore.
not.
Such that.
I don't know if that makes sense. but-
N is bigger than n epsilon.
What are we testing now?
Whether this is a bad assumption or a good assumption, we wanted to destroy it if possible. Because she proposed,
That
if we take both same and then add another fifth one, then one can prove the product.
can we ask that?
I mean, I can prove both of them product, but then everything become trivial, so it does not make
yeah,
sense.
yeah, okay.
To make the theory non-trivial, she is proposing adding this one and make this like this. But the question is whether this
This one hold.
in general makes sense.
But I think
Yeah.
even this one doesn't really make sense in our way of thinking, because like we are used to usual metrics.
No, we are not in usual metrics.
I know, I'm saying.
So it's not anymore
If we
these steps.
we think in our usual way of thinking,
Yeah,
does
where
this
this
make
conflict.
sense? Probably not,
Probably.
but also this doesn't make
Yeah.
sense.
As I said,
But
So it's not-
cannot equate our usual thing.
We have.
So
Because
it's
this
not
is
a
not
good way of.
distance in a real sense, because it's a completely abstract word we are working on. Because it's
Want
not
to show
anymore
convergence.
to.
Yeah.
How do
So
you
geometric sense.
we can let's now assume that this one is a consequence, so we have.
No, we can't just why can we?
It doesn't make
The
much sense.
question is, in a real number, will it contradict?
In real numbers.
Now, we don't know whether this consequence is converges or not.
And
So
We
we
don't
need
know
to.
if it's how she.
we have
How can you?
everything
You need to prove it for me. then.
No, on the other side. I'm saying. Because
We
we are
assume-
the elements of real
No, we
number.
can't just take it for granted. We need to prove things here. Right? Because if we assume things, I can just assume the answer and I'm done. No, look, I'm done.
In order to make things easier, we
No, no,
assume that and we prove it's convergent.
It's not, maybe not.
No, I can't do that.
It may not satisfy
Yeah.
other thing. Okay.
Question, can we construct one that satisfies all the others and fails that? I don't know.
Do we assume that one also?
Xn plus y.
Then we introduce the distance
Why are you
between
putting it in brackets? Xn plus y.
this one.
Yeah.
We assume that is a couch.
It's xn plus yn. We're not assuming it's a, if you want to prove it for me, prove it for me.
We have these three,
Then is a couch first.
Yeah,
then six.
if you want to prove it, I'll be happy. I'll be very happy.
I think I got it.
Can you,
What is an
please,
example
if you
of
can?
semi-ring that's not very okay.
Was I input zero?
Those which on the top or bottom?
No, that's one.
It's a commutative semi.
Why? Why do you have this?
Can we define one?
I was assuming it in terms of.
Yeah,
Oh,
we can,
what is-
the question is that we have to define, say take
But we don't know
subtraction.
what this.
Okay,
See, X and Y and X and
Yeah, I
Y,
think
what are
that's-
they? The elements of X. S is a semi, it's not necessarily a real number, right?
Oh, yeah.
So we don't know what this absolute value of S is.
Of course, it will satisfy.
Yes.
The trick is you,
Yes.
see this, the
That's
X
not very weak.
that's between that and X plus Y. You
I
want to
actually don't
use,
tell me.
you want to use the properties of T
How
to
they
get what you
I
want.
don't tell.
I'm not telling you the answer, I don't know the full answer.
and
This one has the properties of a usual. So that's why we prove using the.
No, no,
absolute value.
no. The usual metric on R is absolute value of X minus Y. 100% agree with you. But we're not working with R. S is a semi-array. It's any semi. So you can't just do absolute value. What's absolute value of X minus Y in a semi-array?
Remember on the same ring, we have two binary operators. So if I don't use the modular, this one might be negative, and then which will.
What's modulus in S? It's not the real numbers. S is a semi-array. What's modulus in a semi-array?
okay.
I don't know. So you tell me then.
No.
So that is the first one. A positive.
I also don't know, I mean, how to
I
define.
think it makes sense,
Yes.
We're trying to assume so that our ring can be positive. It's binary operation. So if I don't use modular, why
You can't do that.
I can say,
X minus Y, yes.
you see?
oh, I was calling that. How we can call it.
You see what I'm talking about.
Don't use modulus.
You see what I'm talking about.
He's using modulus in the semi-ring and getting a point.
Yeah.
So now he saw modulus and he was very happy.
We start.
Now we are on something else, as we are not doing the one.
Okay, please teach him set theory first.
Set theory.
Set the functions.
Okay.
I think
Yes, we do that.
So sets, right? When was say that he showed up at the beginning?
some values, you know.
I don't think it's true.
But let's not judge. Let's prove.
You don't know what is A, B, C, whatever.
I want to make it P,
Yeah.
so it's not.
And it can be labeled by anything, X, Y, E, B, whatever.
It's 9.
So this is 9.
It could be people.
Now I have, I need to choose set such that
They tend to.
3 and 4.
Could be people, could be anything, right? So there's no multiplexes in there.
Yeah.
Okay.
The modular, we will measure the distance
Yeah.
so that we can avoid the non-negative.
If my set is 2, then it's true, because, oh no, it's 1 times 9.
What is this?
That's 9, yeah, it works.
It's the set.
So it's 2, then I get
Yes.
1 times
Sorry.
Eight.
y y 7.
Eight is opposite. Yeah,
So it doesn't hold for this.
Yeah, it doesn't hold. Yeah, it doesn't hold.
So, but minus does not make sense because we are in natural.
Okay, but
So we have to define our distance by some other element. So maybe the maximum value.
Instead of the.
If you have two integer, then max of these two will be.
A, all other names in here. But I can also have B and C. I can have C.
So our D should be say max. D of Mn equal to max of Mn.
You know, pairs like this.
Yes.
What's one?
Beautiful.
yeah, I'm thinking that
You know,
if I
it's fine.
take
It's not
the distance between and n
Yeah.
is where I get n.
Which is not zero.
So it's
Just rationally, you know, let's do X and Y are real numbers. You know, this is just points on your X, Y. You see, sorry, it's not trivial, the function of the use. Now, what's the function? So what's the relation? Cheating and war. What's the relation? So just
All semi-rings which contains the semi-ring of non-negative pairs. Yes. We take S.
what's the relation from the set sheet to the set?
Non-zero R.
What is it?
and then you
Then I change my, keep everything as it is.
you take out the things. But then it's not, it doesn't feel like any type of thing. It's like a vector space type.
Yeah, so vector space, like,
Everything that you is in it.
but it's still within semi-ring, but it contains another semi-ring.
And
But
like,
And I'm not considering as a vector space, I mean, not
This example,
action of this on this, but just an embedding.
AP.
I don't.
So it's a subset.
This will
It doesn't make any sense.
What is the relation? H, B, C.
I mean, it makes sense in a sense, okay, it makes sense, in the sense that, we are working on. It's 7 feet. And, we're working on semi-vector space.
This is going to
You can think like this.
is going to be this.
Instead of taking field, we take a semi-field.
So how is that look like?
And then you take an action on this semi-field
Because every pair.
on your
something
semi.
from A to B is in the whole Cartesian
Yeah,
product 8 times.
But
two.
it's a
But
different.
this is just sum of.
Yeah, of course it will be a different field. It will be semi-field,
Um,
which will be this one, and this embedding will be like that. So you can take an action of this on a semi-ring, so you get a semi-vector space.
And it doesn't look
And
pretty
then you
awesome.
went down
We-
a normal.
I guess that's.
Yeah.
A1 where is part, it will say A1 relate,
So it will be like
we just use the sum.
this.
And what's a function?
Then you actually still generalize. Maybe go around. Semi.
No, yeah, this is just a relation in general. And then Google's relation is a special one,
That will be
That
slightly different
satisfies-
than
reflects.
within
symmetry.
without bringing views.
Reflexive.
I still like
Yeah,
that.
transfer.
I don't know if there are examples that make.
Yeah, I mean,
sense.
of course, that
What's a
counter example
function?
does not mean anything.
No.
Function from
That
say
counter
A to B
example is absolutely.
is a relation.
Only the thing is that we have to find examples, at least some non-trivial example,
Yeah.
which satisfy these 6 actions.
That's A. It is A.
Okay, Maggie, there is a full theory. Completely full theory one can do. In function analysis, you have reals, then you have a vector space like this, okay?
There's only one.
Now we replace this by semi-field. So this will form a semi-field, not only because all non-zero will be invertible in that sense. Then you replace your abelian group by this semi-link, and then you take a semi. And you replace this number 4. Now your S is coming from here.
So meaning this.
Or then you now have S.
Then S can come out.
Yes.
And everything works fine. And nothing will be trivial.
I was just saying this one B comes from A and then this one.
But it is not as good as my initial thing. So I actually put this semi-ring inside my S in some sense. So it's not arbitrary semi-ring, but it contains positive and non-negative real numbers. It still generalizes this whole non-linear spaces. And I don't know even how much mathematics has been done to this generalization. But what Elena suggested, adding this works. Only the question is we have to find some nice examples of such things to support this. If we have examples, this will also work. At least it works theoretically in the sense that these two operations are continuous. Without working in it.
No. That's what I'm suggesting we assume on for as that's the same.
Yeah.
But then we are
Full name. My name is Amartya.
it's like a triangular inequality for the cross.
Now they have 6.
But I didn't have you with them. Sorry. There is a guy for.
I didn't apply for a position at Stellenbosch.
Yeah, you didn't apply for.
Somebody wanted to appoint me.
For social media.
It's for social media.
Social media, I'm so famous. No. I like your idea, what you say.
I don't know if it makes sense.
But do you agree what I suggested will work?
Yes, but it's restrictive.
It's a generalization of nonlinear vector space by semi-field semi-space. So I replace my field by semi-field. You take just positive reals. Every non-zero element is invertible.
Inverse for the sum.
You don't have inverse for some,
But you
but you have
inverse
inverse
for the
for,
product.
okay.
Then you take an action on it on a semi.
Isn't a semi-field just really,
How?
well, like an inverse ring, because it's like you have a group with a multiplication.
No. You don't have additive inverse.
The distributive property is on the,
Yeah, you're right.
no, maybe it's not.
You do not have additive inverse.
Yeah, so semi-field.
No, he's saying this.
Multiplication.
Now I know that it's that for multiplication I have an inverse.
Yeah.
So I take this as addition.
Yeah,
It's my first operation.
No, but distribution is your problem. What? Distributivity property, right?
yeah,
Yeah,
it's
that's
like
what
you
it is.
swap the distribution. Have people studied metrics and rings?
That does not make sense. I don't know why. It only makes sense to study topological rings, where you just make your addition and multiplication continuous. But I haven't even seen this thing, what I am proposing here.
Because I mean, if we're doing it for semi-ring, have people done it for rings?
No, for ring, we have subtraction, and subtraction we don't need in metric space, right? That's the only thing you have there, extra. But doing metric space is all about addition, because you do, I mean, these actions. You never use subtraction.
You don't use addition either because
You use it in
Yeah,
reality.
yeah, on the other side, yeah, that's true, that's true.
But it can be done like.
Yeah, yeah,
this.
everything can be done
Like
here.
this
with the-
becomes trivial for this.
Yeah, it's not quite, Elena, it's not quite bad, including R0.
You are the semi-ring theorist, so you tell me.
Because it's not that quite action we are taking, because then we have to add more axioms there. If I take R0 acting on S as a vector space type things, then I have to add more axioms here. But I'm not doing that. Only I am to manage number 4. I'm just making.
What kind of map is this one?
No, I'm saying we are not doing that.
We are not doing.
We are not doing that.
We are just saying that this is, there is an isomorphic copy of this
Exactly.
inside the same.
Exactly. So I'm only considering semi-rings who contains already are non-negative real semi-ring as a subring. That's it. Just to justify number.
But do you have an example of a semi-ring that contains negative real numbers? That is sub-semi-ring.
Every real number will do that.
Okay, but it's a ring, for the ring.
Yeah. Think you can construct an example taking semi-rings of continuous functions.
Okay, that's possible.
Because you take the values on a semi-ring instead of reals, positive, non-negative reals. And then you take your such a semi-ring. It will contain real by taking alpha times f is alpha f like that. Possibly it can be done.
I was thinking the different,
Yeah, tell me.
but I thought you take continuous functions that have values in
Semi-ring.
positive reals.
Right, yes, yes.
Then constant functions are your positive reals inside.
Yeah. Exactly, I wanted to mean alpha by constant, yeah. I mean, sorry, I wrote in I'm saying that's a constant function going to alpha.
Okay.
Yeah.
And we see.
Yeah, so it will work. So there are such non-trivial semi-rings which contains R plus. Then I think there is no problem, right? Can you prove that? If we have excess y equal to s coming out as a real number, then can you prove the product formula? Yes, it's obvious. Exactly the same proof. What happened?
I was just looking at the first one, but
The addition one?
yeah, the addition one.
Yes.
If we have the one we're adding, where we have x plus n plus s, then we have then S sequences that also converges to SXN converges to X.
Yes.
And also SN converging to SE. But I'm not sure with the mathematics, where we can have both.
Will you please write on the board?
Okay.
Let's see, what is your proof? Yeah, Kishan, can you please take a picture?
And now we have to. Like.
Oh, you right?
Let me just. I just the picture.
Sorry, yes, I just take a picture for.
Yeah, you remove the right hand side because that
Yeah,
was
it
experiment.
erased. Yeah.
Okay.
Everything you removed. What is written on black? You can remove the bottom one also. You see, you are only left here. Everybody. Nobody likes this.
Mathematics, but yeah, maybe if you assist with the example, they will know the right answer.
Okay, so how I try to prove continuity, but I'm not sure if it really applies to the two extremes. But I was just trying to observe how this can tend to.
No, we are not proving that.
Oh yes. Oh yeah, we're not proving that, right?
We are proving addition is continuous.
It's continuous.
We are not proving any one of these. These are axioms. We are using this to prove those two right things what I wrote on the right hand side.
There's xn plus y then goes to x plus 1. And also x and y then goes to x1, the product.
Yes. Okay, so let me just write and then we can. We can make
Sure,
up.
sure.
So
Please,
that-
please, please.
Then maybe I'm not getting it properly. So. Let me start with I continue. And zero. Then is into the search that we have the distance of x plus y. Oh, not y. It's supposed to be s. And from x goes to 9 plus this one is should be less than delta. Then data exists. And and have what
I don't understand. You wrote something less than delta equal to something less than.
oh no, not equal to.
Ah,
Let me have it. This is not equal to. Yes, actually, no, it was just to say that.
So you have 1, 2, 3, 4 sequences.
Yes,
Okay.
yes. Also, in the case where we have just this one, we can.
No, what you wanted to show.
Oh yes. So. Yeah, so this is what I wanted to show for addition, and then
Where,
I wanted to.
I don't understand. I don't understand. What you wanted to show.
Like if like we had these sequences to be continuous,
Which sequences is continuous? No sequences is continuous.
Oh, it's not good.
Addition is continuous. That's what you wanted to show. Sequence cannot be continuous. It does not make sense. Sequence can converge.
Okay, oh yes, yes, not yes, okay, fine. The sequence can converge
Yes.
to X.
Yes. So Xn converge to X. That's your assumption.
Yes.
Very
And
good.
then also Sn also
Goes to S.
S to S.
Yn goes to Y. Sn prime goes to S prime. Okay. You have, okay, I understood. Yes. Then,
Which to X to X.
yes.
And then we'll have this X. We just say X and we take just part of it to say as S to 0. Then we're gonna have
That's you have to prove.
this one.
Yes.
We'll say for the other side.
It is not.
Do you mind if I just?
Oh, approaches, yeah, approaches is not approaches.
You wanted to show both.
Yes, so those are things.
Why?
Um.
Why should I do more work? Did you follow what I'm saying?
I think I probably begin with this.
Right, so did you understand the usual function analysis? How we prove this addition and scalar multiplication continuous?
I think I have to have a video.
This is the thing, never read mathematics. It will completely destroy you. Do it by yourself, and that's why you are trying to prove the same thing twice.
Okay.
How we prove the usual one? Forget about what I'm talking about. Okay? How we prove the usual one? We start with two converging sequences. And then we wanted to show xn plus yn goes to x plus 1. Okay? Then similarly other one. So let's forget about the multiplication, only addition. So forget about what is we are proposing here. Can you prove this thing using the metric?
Using that equation there.
Which equation? Yeah, that's what I'm saying, that just using triangular inequality in a metric space, you don't need nothing more than that. Just use this number 3. Forget about this semiting everything. Just go back to your original one. Using this phrase, prove that these two implies this. If you can do that, then you will be able to do that. And if you cannot do that, of course you cannot do this. So try to prove what you were supposed to prove before.
So I can use this.
Yeah.
To prove this.
Yeah. That you need to first do, because if you cannot do that, then this will be not possible, because it's exactly the similar thing what we are doing.
Right.
I still think something is a great example.
Internet area. Where he was presenting. Is your just
Then that's according to some schools. Do that job. I wanted to make a revolution in South Africa. And I see it's impossible because we don't want revolution. I do not want to be vice president and just put it in my CV and show people,
Then you
look,
just should.
look, I'm no. I had some A, B, C, D items I wanted to change in this world. And when I see it is not going to happen.
So that is the only usually that the vice should be ending out.
Just handing out the price end of the year and that's it. I make it ready.
They pay for you to attend. You don't even do the bookings and everything, you just really wait for the award. Then you do the submission. So if it's in Prashara, you go on that day for the award, and then after that in between.
No, of course, you collect this reviewers report for the nomination person. That will become good for people. Your job is only to look after of these two prizes. You send email to the referees. Collect the three referees report, compare it. Is it good? Good. You know, that's it. So I do not want it to be such a puppet.
So these 3 years have been you.
No, this is my first year, and this is my last year.
One of those two.
Or you just, this was your first year.
At the end. But I get away.
It's not like going chase my CVs in the
That's still between exams. So.
What?
Is
My tools.
which one? The one of the same.
How many members we have interested in members, that's this one.
But it's the same thing. Since we're here focus on that. And then you might reach time without the heads. Maybe whatever you use that. No, I'm saying you reach.
We just sitting there with the name and designation. And I'm having either have your wife. Get out from me. And I don't like that.
So this year you will be exams.
I will be there. This will be the first and last year. Shituti told me, please reconsider your resignation, come back again. And Shituti very much like to me to reconsider my decision. Okay, we are at 4, right? We have some other things to do from 4.
From 4, what are we doing? According to the program.
According to the program, I think we concretize those things, the scholarship, how to do.
Or the.
Oh, no, we said that we will continue, right? We will not discuss now, we carry on now, yes, sir. Because we will do it between, during the food. Or last half an hour of this session.
Okay. Where did the meds go, guys? The meds has run away.
Oh, this one.
Yeah, to shrub that one.
Come on, the years.
Yeah.
Come up with your own theorem is not easy.
No, but the Prof has explained what you should be doing. They said in the matrix setting, you just prove the triangle inequality of this is the triangle inequality. Forget about the new structure. This is the triangle inequality. Just prove this. This is the one. That if xn goes to x and yn goes to y, prove this one using the triangle inequality. Only the triangle inequality. And also this one. So you are just working on this, only the matrix setting for the triangle inequality. That is what you should be doing. Did I interpret you correctly? You forget about the rest. You know the matrix space. This is the triangle inequality. Now, prove that this, when you've got this, these two will hold only for the triangle inequality. How do we prove the triangle inequality? So then use this one to get this part here. That is all that we must do.
So now we are not here, we are not introducing Z.
No. Forget about the Z and the X. Prof has explained, he said that now look at this one, do this one with what I've just pointed there. Prove that one, that xn plus yn will go to x plus 1. If your xn goes to x and your yn goes to 1. That's what you must be proving. How do you prove that? I interpreted you correctly, but
We are not doing any new mathematics.
there is no new mathematics. We just use the metric setting. We prove the triangle inequality. Just use the metric.
Separation between mathematics and the finance. You gotta really you can't separate. You don't like go to the top.
You killed me.
With what?
You didn't tell me.
I wasn't told as well, it was a surprise. They came to connect me and then they said they want to interview me. So why should I be the?
Now you beat the one
She was surprised as well.
You have to face what you are doing. Because
Can you make
I'm gonna leave this action.
That's very great. When was it?
Speak to the front, think it's gay. Yeah,
Maybe in the bathroom?
Yeah.
Excellent. Just 2 days. It's right. Thanks. Right. Just 2. You know, you're coming on something.
Yes.
It's like a police.
Just that.
More let define that in your concept. Yes, more research on
You are proving something.
and only welcome.
Manje concern wabuzile but amana.
So complete.
That's bad.
Yeah, but I enjoy him for you.
Yeah.
You can enjoy him. We can be
So you can go fishing.
You need it too.
I are cooking, brother. Cooking. There is only one day was to. You're no longer cooking. I feel like it's take messing us. Sometimes I was scared of.
Since giving new ideas.
Yes, the spirit of it should be that kind of. That is and the best way to learn is to use stupid. Because you understand, huh? I'm sorry. Yeah, yeah.
Manje,
Come on.
what I
Malawi Jimmy Ramaka. Ah,
Mana, that's what rest.
Atanate. Atamel.
Sabona fana go rest.
Nanga sobulisho ngoba ngiphekile wabayithi bathokela bamabheke. Nanga sobulisho ngakela zona.
And you don't even think about cooking. And you be
Bana akumela isina beans of it was the news such thing when you change not
I mean, they will say, okay, they don't talk about their
you know what as ability in July like yeah stop like to and it's just something just that they want higher achievement like say and you must keep up with the standard chief otherwise you'll cry I will cry
otherwise we're talking.
let's see so after that
I'm shy coffee. Shy coffee.
never take cappuccino coffee
And then there's the drink. Inside the fridge. There's cold.
I'm just giving you the idea of a feeling to one of them.
Yeah, guy, can I go right?
So you're saying XY approaches zero. What's the difference between XY approaches zero? You're saying the distance between XY approaches the distance between X and
Agree, it is absolutely closer to zero.
Yeah, I'm reading what you wrote.
Yeah. I'm just giving you the idea of
Yeah, guy.
I'm on things, right?
So when you see this, you're saying deep.
Yeah. That's when the patent go team. Instead of more open for together.
Changing it after you have accepted saving was done.
Bring mathematical ideas. But where the prove take this one, take this one. So this one converts this is that prove this one, this one. This one is this one.
Respondent Sabulini. Yes, moving. You didn't get the answer. You didn't get the answer. See what are you saying to me? What is the question?
Oh, What if X converges to X and then Y and converges to then to Y, the X converges to X plus.
And then when you multiply again, same.
Another whole.
Mara, Mara, so one of it, Mara.
Don't do it, no wrong. So,
Mara, okay.
no give me another charge or
Mara, Malose, when you say something approaches,
Yeah.
something, there's that one of. Basically, the answer is forever. The more you know everything, we can say that and then we have a situation where we are talking about limits. Let's say is it
no. And from there, I'm not even to manipulate this one.
not only he's gonna come and say, what do you mean? More like you're proving it.
Using mean when you say X, Y.
This one.
That's still proving. The triangle. That's what you have been doing since I left.
Oh, Malose.
Oh, I think you were showing that what I want to show that your X then converge to X. Yeah, you must show this one. So I'll give this one. If this one converges to this one. Oh, which one have you done? This one. This one converges to this one. Which one have you done? Finally, this one. Which one have you done? This one. I think that's what we've been doing since I left. So you're breaking our mind. We don't didn't do anything.
No, at least we know what we need to do. Like, I was like, you know, the distance between X and
Wait.
plus.
Are you from Fisk? Sorry. Did you do all the?
They just needed like Mabatinga when I failed.
No, when you were in third year or second. I don't know. No, not a physics. Like math. Yes. What year did you do mathematics?
What did you call it?
Third year.
Korea. The interview.
You've been doing math with mathematics. And we do all the math. Oh,
I was telling Collen that we were doing a presentation.
you didn't do all of it. Which one did you win?
I'm saying we were doing a presentation. When they called me from and then
no, you did topology too. The presentation. Yeah, I presentation or interview. So it means you did all the mathematics then. You did all the maths.
We were claiming the theorem, so now it's.
Oh, you don't.
You know, I never thought in my life I would come to a point
When you are trying
category theory.
that's what I say.
You'll see you were in shock too now.
That's what I
Because it.
understand what each step means. You understand
It's fine, kitchen.
oh. For you, pyramids, intentional. That's why you see in the class now, I don't like giving you proofs because I know you cram.
You must give them proofs on Tuesday.
Try to understand those steps. They have meaning, you see. Step proof. What am I doing from this step to this step? You know, I'm sure that Xn is bounded. What do I mean by what the definition of this? Let me get me myself a lot.
So what did they?
I can that's some question.
Yeah, so.
And then would you use to tie hands us?
I'm correlating the person who had to do sometimes
Terrorize us that
this is a criminal.
It's terrorism.
I told you, my brother. Yeah, you're getting your ball.
Azum. Azum. Okay, I can break it down. Azum. Azum. I don't know how. Azum. Okay, we get this one. Hey, Azum.
All good. All good. Bella chiamata. No.
What are you ready?
Nah, it's nothing deep. It's com skills.
Tutorial.
It's like life orientation.
It's tutorial or major test.
The major. It's open book.
Open book.
West.
This is not maths. This is I know open books of math. Just not gonna waste your time bringing a book. And it's time.
The 2 weeks. No change.
That's when I was in high school, my teacher was saying that it's open book. I was saying that.
We were like,
Yeah, but it's not maths, which is nice.
When I don't open book, you open ChatGPT. You say you don't open book. It's not open ChatGPT.
What are you doing? GPT, your bed.
It's like a com skills. It's computer skills. Computer skills thing. It doesn't take a lot of. No, I done it first year.
That is why
Just open ChatGPT.
And I'm done.
Yeah.
Make sure that right now it's like Excel. So it's gonna show us Excel.
I'm saying no, but
No. Now I'm gonna start writing at 5:30.
Yeah, this week, what are you doing this year?
My modules. have geology, GIT. GIT is geographical information systems. It's like satellites making maps.
They were not mapping geographical.
Yeah, those things.
A photo map.
Yeah, now I'm making them, boy. Now I'm making them and
Calculate the spatial data.
it's quite nice. Really.
Faster. Yeah.
But it gets better. It gets better. Like you can like track animals. For us, it has more.
You track animals how? From the you get the map and then
You can get the map. Then if you have relevant sensors, you can track how the, let's say, distribution of what we have instead of chickens.
Calculate this load of chickens. Calculate this.
Maybe use most of the time for the photo, and topographic. You play with them. It goes with how you collected your data. Such as now we were doing a storytelling. For instance, they can say in Pretoria, and they can say, make a map that tells how the weather affects people in Pretoria. First, you're gonna find the map as you know it, plain map. Then you have to get data, literal data. You're gonna outsource it from satellites, databases, and it's gonna show you how people are distributed in Pretoria. Now, you can also find with both who has money, which side, and who has money where now. Therefore, you can now say, find the weather one from South Africa's weather service and put it there. Then you try to find a pattern over it of, okay, we see that there's more rain in the rurals more than in the suburbs. And it's impacting them because they're not affording, they don't have proper infrastructure for those rainy seasons. This type of thing is. But right now, the one I'm gonna do, hopefully it's calm and ChatGPT, it's ChatGPT-able.
Yeah.
No, I'm serious.
Good luck.
I think the store is tired now.
yeah.
Do you see it?
I'm going outside.
Yeah, I don't know. The motors.
Read my bed. Rodrigue has zoomed.
Now we're continuing with the same session. Maybe the
That face, what we should do.
Well, if you go there,
You take pictures of what we do in the session.
We're doing
Who took pictures of what we do in the
Prof,
session?
even Prof Zurab. If you may ask to send.
category theorem versus graph. Combining them.
Yeah, something of that angle.
Because you are doing exactly what you want. But if I tell you what you and just find out.
That's true.
I wasn't, yeah, you were both
The class. The online class testimony. That should be easy. It was split.
Yeah.
Easy to get.
I can see that.
Welcome back, everyone.
What do you think?
We are now at our last session, last formal session. Of course, tomorrow we're going to continue some of the activities, but this is the last formal session from 4:30 to 6:30, where we're supposed to continue progress with the research questions. But I'd like to suggest that at least from the beginning, we can instead report to each other briefly what transpired in each session. And maybe the students from those sessions can do that. I think it'll be a nice experience for them to do that. Maybe first we can begin with your question because everything is already written on the board. And some student from our session could also say what we did. It could be a very short presentation, 5 minutes should be enough. Just an overview, a very broad overview. We can begin with that. And then after that, we can talk about future study plans for the students, whether it is cost of provision from one of the lead researchers or core researchers or the focus area, whether it is applying to a different university for the next study. Professor Aphane and I were discussing that possibility. So we can talk about what is on the wish list. And when we're done with that part, then after that we can decide what we want to do further on. Okay, so then let's begin with reporting. And I'd like to invite Team 1. Any student from Team 1 would like to, or maybe 2 students or 3, would like to come to the board and explain what happened on, what progress was made on research question 1.
Absolutely. I think so.
I see someone has volunteered already.
Good afternoon, everyone. So I don't know if we made some progress, but we were still trying to figure out how to go around this research question. So if I miss anything, maybe one of my colleagues will help me around. To explain more what's happening with the question, we were trying to see if we have this x n to be if xn converges to x, we have yn sequence yn converges to y. Are we able to prove that if we have the addition of those 2 sequences to be converges to x plus y? Yeah. And also with the multiplication here, to converge to xy. So using, of course, some axioms in metric spaces. So this was one of the attempts my colleague tried to do. We didn't really discuss how it goes, but we cannot start with the fact that the sequences are continuous. So we really have to begin where we have them just as simple structures we know in metric space. Yes. So we were trying to prove this one because it looks a bit more less complicated than the one in this one. But these are all assumptions. We tried to see that if they're just assumptions, and is it possible to prove these two, where if we have these conditions, and I do think it is possible, prove that if, given that we have xn converges to x, and also yn converges to y, then we could definitely have some form of proof to have that if we have if we add these two sequences, then can converge to x plus y. So we haven't really made much progress. So
Sorry, can I interrupt you? Research question 1 reads, how to define metric on a semi-ring?
yes.
Have you answered that question?
So with the definition of a semi-ring, we have the addition and the multiplication axioms, and then we try to incorporate them into the metric. So this is how normally the metric would look like if it was in addition, assuming that we have these elements x, y, z, s, and s prime in the semi-ring. Then we have these this addition of both of them, which is satisfying the one of the laws of a semi-ring, but now we've put them into a metric. So these are the assumptions that we would have if we would have instead of the set in the metric, we'll have a semi-ring as the points in the semi-ring as the distances between the two sets of the semi-ring. And also semi-ring has a multiplication commutative, it's a commutative monoid. So we're also considering having the product, which could be one of the elements of the semi-ring, and trying to see if we can have a sort of a distance between those two different products.
Sorry, I can't help. If I look at axiom 5, actually, do you have an example in mind? Because if these were numbers, for instance, then I think axioms 5 and 4 would force exy to equal. So if you take x plus x, for instance, if s is equal to x, but anyway, never mind what I'm thinking. But what I'm trying to say is that is there a specific example that you found that fits this definition?
Looking at it the way it is, I don't really have, unless we have probably we could use, if we're using numbers of semi-ring.
I'm not asking you to come up with something on the spot. I'm asking if in your session you discussed an example.
No, not really. We haven't really discussed any example, but my thoughts concerning a structure that we like, probably one of the axioms we might be able to satisfy the first, I think is this, the first axiom that we have today. Using probably have D. It's just as what I we're thinking, that it's commutative, you can have it as X, Y, or Y, X. Then this would be equal to 0. And then and try to have it as a additive one. From additive, we have suppose Y. X. Because
What are you trying to do there?
I was just trying to prove the second, no, not the second, the first one. The structure of a scenery.
To prove it.
To show how it can look around in a scenery structure. Leaks, nothing to add.
Maybe just give the others so that they can present what is it that is supposed to do. Let them answer the same question.
Not the same question.
Yes, what is it that what the research question was?
Uh, so, so the aim of the session, we're trying to incorporate the same ring into a metric, right? Because as the research question said, trying to define a metric on a same ring. So the only problem we had was trying to prove these conditions. Because we were given time to try and prove if this is true using because we know that xn converges to x and that yn converges to to y. So now we're trying to prove that xn plus yn converges to x and y, meaning we'll be able to both of them, right? She's saying that. Okay. So now we know from the Cauchy sequence that for all epsilon greater than 0, there exists that. So if we use this equation here, especially the inequality, and try and prove one of these, that's what we were trying to do. But
You were trying to deduce 4 and 5 from 1 to 3.
From 3 and deduce 4 and 5. That's what we thought we were trying to do as students.
Okay, who was working on the board?
Prof.
Okay.
That's what I thought I was doing.
Professor Goswami, you didn't let them work on the board.
So they are working on their exercise books.
I see, I see.
Yes. I don't know if
The last one I explain. I want each and every one of
Yeah,
them
that's a good idea. Yeah.
Then You give it to the last one, they tell us what is it that they've been doing.
Okay.
Yeah, so if you are done, if that was the research question for group one. If you
Yes.
explain to everyone, what is it that
Brother.
According to my perspective, we were trying to combine the semi-ring and the metric spaces. So we were trying to come up with a new definition between the metric spaces and the semi-ring. So we actually proved the first one and the second one. So we were trying to prove the last axiom using this definition if xn converges to xy to x and then yn converges to y, then this condition is satisfied. So this is how I attended the question, that we know that since epsilon is, we given epsilon greater than 0, then there exists a n that such that is belong to a natural number, and then we were trying to prove this. So since we know that this thing is less than epsilon and this one is less than epsilon, then from the definition of the distance, we can find the summation of these ones. So from the summation of this one, I try to use the triangle inequality. So when I try to use the triangle inequality, I reduce to this, then it reached to this, which proved this one. Then since our arbitrary element is closer to 0, then we can assume that this one and this one approaches 0. Thus the distance between x and y gives this one, and this one gives this one. Hence, we prove the theorem. So that was according to my perspective. So
You prove that if xn approaches x and yn approaches y, then the sum of xn and yn will approach x plus y. And you prove that using the axioms 1 to 5.
yes.
And what was the purpose of that? Why were you trying to prove that specific property? Was it kind of to test how good the axioms are?
Yeah, and then again, we were trying to satisfy this property using this property here. So that if this one is continuous, then this property might be satisfied for ring and the metric spaces. I don't know if
It's not your fault. This is the situation, Prof. From the definition of a metric, your D is mapping from X cross X into R. Then we've got property 1 to 3. What we did is a new definition. We now have our D mapping from X cross X, which is a into R. So we just have to put the definitions that we in this point, if
What holds?
these properties 1 to 4, and then there was also an addition of properties 6.
It holds for there is property 6. Holds for which lecture?
Then this is flow. Another question. What are the right set of axioms for defining a metric on a semi-ring such that your semi-ring operations are continuous? Your questions are this addition and
Can't you require that as an exit?
sorry.
Can't you require that as an exit?
Yeah, of course you can do that. So. Those, of course, these three need, but the proposal was 4 and 5, something like that. We are playing with that. To see how addition and multiplication can prove. So then becomes a topological semine induces by this metric. And then once you have that, then you can define norm and then you can do some kind of analysis.
So far, your answer to research question 1 is those 5 or 6 axioms.
Yes, but there are some issues and we realized it need to be some modifications. Require some alteration, otherwise theory would be trivial. So still some work need to be done, but with proper adjustment, it is possible actually to come up with a set of actions. To literally redo these non-linear things in a more general setup, more general.
And was it fun?
It was challenging.
It was challenging.
Okay. Any other questions? I mean, sorry, I asked all the questions so far. Any other questions?
Now it's there, right? Okay, Zurab.
Yes.
Whom should I give this thing first?
Oh, they can volunteer themselves. You don't have to pick.
Okay. So who wanted to come on the board? I'm holding here. Because you are class.
Can someone maybe take a picture of the board so we can erase it for our part?
We already did, yeah.
Okay.
Of course, why not? So let's remove everything.
It's fine. Yeah.
No. That thing came out, right?
Okay, good afternoon or evening. Just to give a little bit of insight as to what we're busy that side. My colleagues will add things that maybe I might have missed, or maybe things that I might maybe misrepresent, well, not on purpose. But then, yeah, the research question, are the hidden categories behind graphs as studied in graph theory or its application, right? So from that, what we then try to do is that we then try to take a scenario in graph theory, right? So from taking that scenario in graph theory, see how we can now put categories into that and see what then happens from that situation, right? So the first thing that we did was we did something like this. We had cities, Bloom, we had, I think it was Cape. Was also Pretoria. Just
There was that no, somewhere here there was Durban. Then the last one was what's the last one?
Yeah, it was okay.
Okay, yes. So what we did was we treated cities as our vertices, right? So and then we represented it this way. There was representation of okay. There we had also prices. So this is us trying to calculate traveling costs. There we had prices. I'll just give just an estimation of prices, not because I'm not remembering the exact figures, but I think there was something like 3,000. Then from Bloom to PT was 2,000. It was 4,000.
One way.
Hmm?
One way.
Yes, it was just rough estimations. I think this was also then from this arrow of 6,000 was an arrow where you are traveling through PTA. So where you are traveling from Cape Town to Pretoria, then to Durban, right? So from this, we use a notion of directed graphs, right? As you can see that there's direction from one point to the other, or from one vertices to the other, right? So when we then try to bring in our categories, right? We then saw that, wait, before then, we know that when we are traveling around cities, right, it's possible that when you get to Pretoria, you might maybe need to wait in between. Maybe you have to wait in between flight, or maybe there's also accommodation if maybe you are staying overnight. So those are factors that can have an impact on you traveling from one city to the other or from one location to the other. So taking into consideration those factors, right, we then had a question that how can we optimize traveling costs. So it then led us to this question. Now, from all of these things, how can you now minimize the traveling cost from traveling from one city to the other, right? So when we, obviously this is us trying to answer the question of how are there any hidden applications of categories in graph theory. So obviously now these are the factors that are there. We found that there's a time factor, the costs also. Now, I'm not sure if I'm missing other ones. So this now became, we also had a problem where now that we have to calculate the financial costs and the whatnot. So there's also that question that before we can answer the optimization problem, and how can we solve the prices with relation to time, city, because different cities have different accommodations and different traveling prices and whatnot. So that was for the one part of the problem that we looked into. I'm not sure if I missed anything. I'll just give it to my colleagues so that they can add a thing or two. So now we had another interesting look at the problem, right?
where from this problem, what we then did is that from this, we also, try to come with a term for this kind of a category, right? Where we called it the cost category. Right, because we were looking at the cost where the cost of traveling, the expenses and everything that happens with traveling. So now, the other interesting problem that we came across was that, let me just try to roughly draw what we had. Right. So from this structure, we have a molecular structure. Just forgot the name of the molecular structure. But then the most interesting part is that from this, what we then brought forth as suggestions, as questions and whatnot was that we looked at the direction of this. Specifically, we looked at the electrons, how electrons are affected if maybe we were to remove this hydrogen, for an example. What would then happen to that, right? But also what was very interesting to look into was that, let's take an instance whereby we have 3 atoms.
I don't understand. How you remove H? How you remove H? Because he has valency 4.
He has valency 4.
Right?
No, it's, how to explain it? If maybe, let's say, the hydrogen had to move somehow.
What happens to the bond?
Yes, what happens? We are only focusing on the
That's the
bond.
question.
It was just an estimation of a problem, not necessarily that, yes.
The question Prof is asking is what happened to the bond that was attached to the
Yes.
Oh, the bond.
You cannot.
Oh, okay. So what happened to the bond is that it's going to attach to the oxygen.
Well, my chemistry is wrong, but carry on.
Okay, yes. So what we also looked into is that since elements or rather molecular structures are connected to each other, is that how can we now find the relationship in between this atoms, right? From A to B, let's say maybe they are connected, and how do they connect to C, right? So also we have this, right? So, but then what we also agreed upon is that we do agree? No, I don't think we agree, but based on what I saw, right? So I saw something that's very interesting, is that when we have a structure like this, where it has electrons, and electrons, right? So this structure satisfies a certain kind of a category, whereby this electrons, they have they map to other electrons in there, oxygen. And then this one, since the force of the oxygen is greater than the ones of the hydrogen, whereby now the oxygen will take the hydrogens will take the electrons from the hydrogens, then we have arrows that are showing inwards, right? So what then happens is that we only have something like this, which are the protons that are remaining. So from this structure, it's a representation of a certain kind of a category. Well, I'm not sure if I represented the group properly, but this kind of category would maybe call it a molecular category, whereby we are now focusing on electrons and the maybe we can just focus on the strength. Or okay, if they have equal strength, then how does A relate to C in terms of strength? If this one is pulling an electron, this one has a stronger power to pull the other electrons. How do they relate now? How does A relate to C? Even in this case, obviously, how do they relate to the oxygen? Yeah. Yes. So yeah, I try to represent, and this one we call the molecular category. Whereby we study the molecules in the category of molecules. My colleagues, anything to add?
Okay, maybe. All right.
Good afternoon. Okay, so our research topic was, can I read it again?
Sorry, let me show it on screen again. And now suddenly lost control of the screen.
I think it's in our group, right?
Sorry?
In our group.
There we go. I think I found it. It's on this one. There it is.
Okay, so yeah, our research topic, our research question, sorry, was, are there hidden categories behind graphs and studied in graph theory for its applications, right? So when you talk about categories, we're just talking about the relationship, I will call it that way, maybe from point A to B. And then when we talk about graphs, this is a representation of it, or rather, this can be represented in a graph form. So when you look at categories, we want a simpler way or the cheaper way to get from the other point to another point. That's what we are thinking about. So this representation was, how do we get to Durban from Bloemfontein? We are looking at the simpler way, or rather at the easier way, or at costless way to reach to Durban from Bloemfontein. And then there was another way from the representation we did from Bloemfontein straight to Durban. And it was, I think, I will say 5,000. And then we said the simpler way to get to Durban from Bloemfontein to Durban was to just go straight from Bloemfontein to Durban instead of bypassing all these places. But then another question that was interesting was, now what if we cancel that road? What then becomes, how do we get to Durban easily or without cost? Right? And then we used graphs. My colleague, he mentioned that in this case, you see that you have to go via different places for you to be in Durban. You can be from Bloemfontein, Cape Town, Pretoria, and then Durban, from Bloemfontein, Pretoria to Durban, or from Bloemfontein to Cape Town and then Pretoria. I did mention that there are different ways. Then how do we then get to Durban quicker? Because now when you leave from Bloemfontein to Cape Town, you might find something interesting and that might waste your time. And obviously you will need a place to sleep. That means you use more money. That's what we were doing. And then we had another representation whereby he said we are from Maths department, and then these are races around Maths department. And then we are saying we were looking at the shortest distance from races to Maths department, right? And then another question that came was, what if now there is a mountain? When I go to Maths department, maybe I'm just going down, and then when I come back, now it's a mountain. What will happen to the time? When I go to maths department, I can go for 5 minutes, but when I have to go back to rest, now I'm taking longer. So yeah, those were the kind of things that we were looking at. But I think my colleague, yeah, he, yeah. Thank you.
That is escape. Yeah. Well, so we were, as you all know, in category like graphs are okay, let me start by saying this. So in category, we know that category is if we have a collection of objects, and these objects, they can be sets, graphs, and so basically now along these sets, we use the graphs as the sets. So now as you can see, our research question was that we tried to bring up this problem in such a way that we can sort of try to solve costs between the cities, right? Using optimization in a more applicable way. I don't know if I'm putting it in an understandable way so far, or should I proceed? Should continue. So what we did is that we said, okay, if I want to travel, right, and then between the cities, using Devon as our destination, which way or which route could be the most or least costly? So what we did was that, okay, since then we see different paths, and as you know, these are morphisms. So in category, you get these morphisms. So along the way, we were discussing that, okay, what are the possible things that could make your journey to Devon more costly? Which factors could affect your trip? And then we asked ourselves, okay, you want to go from Bloom to Devon. First of all, which transport system or method are you gonna use? Are you going to use a plane, a bus, such things? And then if so, which season or time are you going to be traveling in? And again, we used, I think the other factors were the availability of the transport kind or to use from Bloom to Devon. So now we wanted to sort of come up with a differential equation or model to sort of come up with a model that will sort of predict the most or the most cheapest way for you to get from Bloom to Devon. So considering those factors, we checked. We found out that okay, this might need more time or to discuss incorporating those hidden. Remember in graphs, we in under graph theory, we normally discard so many things. So now because of into category, we consider other hidden or factors that are oftenly overlooked by graphs, isn't it? So now our job was to, okay, now can we find an optimization model that we can build so that you can sort of predict the cost that will be the cheapest from Devon, from Bloom to Devon. And then considering those factors, the ones that I mentioned, like availability of the transport, there are many factors that could happen. Let's say you went from Bloom to PTA and then maybe it's late, you might need accommodation, you might need whatever. So such things. And when it comes to this one, we had a benzene ring. So now I think my colleague forgot to indicate that this should be directed, right?
Directed. This is directed.
Yes, because remember in category.
But in chemical, what do you mean by directed?
Okay, let's say now, let's say our bonds, let me label this carbon as C2, C3.
First of all, this is wrong. What is written here? You have to add H there because it C6H6, if it is a just of engineering. All of them H should be there. And I do not understand what you mean by arrow in a chemical bonding.
Remember now, we are trying to incorporate graphs into categories.
It should be undirected graph.
Should be undirected.
Because as a chemical bonding, I don't see why there is an arrow from down to up or up to down. Chemically, it doesn't make sense. So why should I have a direction?
Oh, Prof, I think, I think, Prof, by the arrow, he's showing the relation from which C to which C. I don't know if I make sense. Not to say now it's a bond.
A bond does not have a direction.
Yes, I'm saying
it's
he's
more
saying
like
we
a
look from maybe the first carbon, and then this C goes to another C. I don't know if I make sense that way.
No, that makes sense. What do you mean by the first carbon? What do you mean by the first carbon? There is no first carbon.
No, we look in a sense of these carbon, they are sharing electrons, right?
Yes, they are sharing valencies, yes.
Yes. So we look at how these electrons are transferred. That's the direction that I think he was trying to do.
Good day. So, Prof, we have we tried to answer that question basically using we came up with two categories. This one we called it the cost category, and then we also built another one we called a molecular category. So what is it that we're trying to do? Under graph theory, this is very a simple question to answer. How can we optimize traveling costs? Yes, using using graph theory, basically very simple. We are going to, if this is direction or if this is like the cost of money, then we are obviously going to use the least path to get here. But we are not using graphs. We are using categories in graphs. So basically, using categories, we have to descript this graph here. Using we have to take into consideration other factors that may be affecting this traveling costs. So we determine our factors. We came up with time factors that might be that we might have to take into consideration. We also came up with the transportation type of transportation we'll be using. So we came up with all those factors, and then how can I put it? So we came up with all those factors and then tried to basically answer this. But I think at the end we couldn't because it was just too many factors to. So we moved on to this molecular category here because we thought maybe it might be a simple model to build. so that we can incorporate categories into graph theory. So here we had a molecular structure like this, and then we try to, because when we talk about categories, we are obviously talking about the composition and the relation between different objects or yeah, in a structure, you are trying to describe that structure using how can I put it? I should make sense in my head, but I'm trying to find ways. So in this model here, we obviously know that we can't, like scientifically, it's not possible in chemistry to have directed chemical bonds like this. So we said, oh, okay, if we have a vertex like this, and then there's our thing. Okay. So we said, oh, okay. So if we don't know can we use category structures to basically determine the chemical graph that we have here? And then we thought, because we have to have directed, our edges have to be directed, but it's not scientifically possible to have that in chemistry. Can we come up with a way to maybe model our edges in such a way that there might be some sort of a direction? So we thought, oh, okay, maybe we might break this bond here, and then to break this bond here, it means when we break this bond here, it means this there's one, because this H atom here and this oxygen atom here, it means one electron is going to come here, and then the other electron is going to come here. So so we basically try to use electrons as our way to direct our edges and try to find a way to build a composite sketch using the movement of electrons, because we do know that electrons, they can move around and they can move in a certain direction. They can move this way, they can move. So we try to go that route using electrons so that we can have directed what do I call this? You see, so yeah, it was basically something like that, because even there, it was something like that. But this one made sense when we were doing it. Now I don't know why are we forgetting it now, but maybe Prof.
I think to answer Professor Goswami's question, sorry, he was asking how we choose the direction, and you already kind of gave a hint, but then the example you gave was a bit confusing. So isn't it the case that O and H share one electron?
Okay. In chemistry, right? Right. Yeah, the structure, something. This. Okay. So we have that, right? In chemistry, this is what we have. So what happens is, in a bond, this is coming with an electron, this is coming with to make a bond. And the bonds are not here or here, they are throughout the edge, right? The bond. The electrons are throughout the bond. They are not stuck in one place. They are moving throughout the bond. But now, this
during chemical reaction, this can break away. When this break away, it will become positive, meaning it's missing that electron. And the reason why it's missing that electron, because this has more electrons, it will tend to keep the electron that was with this, and then you will have something like this. This will be negative, right? That's in a chemical reaction. Now, when this happens, you can have something like this also. For this to be stable, you can have something like this. And when you have something like this will now have 1, 2, 3, we'll have 1, 2, 3, 4, 5. But this cannot have more than 5. It can only have 4. So this will keep on, you'll keep on having a reaction to balance that. But let's get out of there, okay? We'll leave it as this coming back here. So now, the next thing is, in graph theory, we have this structure here. I will include with the, okay, let me represent this one. We'll have this structure here. In graph theory, we are not concerned with the reactions that happens in a chemical structure. And which is where now the category of this would be different, because with category, everything else can be included in terms of reactions, in terms of which carbon will, which atom will tend to take electrons from the other one, and that will depend on the whether the carbon has more electrons deficiency or what or not. So those are the kind of things that you look at when you're looking at categories. But in graph, we are not looking at that. So meaning for this chemical molecular category, we will have to check first from here. Can we be able to identify by just looking at this without having the knowledge of this? Can we be able to identify which one was carbon, which one was oxygen? Because when we draw this in terms of graphs, we're just drawing the vertices to be the same, right? So when the vertices are the same, we have something like this. But chemically, we have oxygen and carbons. So meaning they are different atoms. Now, those different atoms, obviously they have different reactions, right? So what category can we get out of this? But now, in order to do that, there has to be some deeper understanding of chemistry in terms of the reactions that happens there, the energies that happens to each carbon. Now there was a question, another question of, if we have, I'll just draw it this way, A, B, C, right? We have a connection, a molecule like this, or a compound like this. In graph theory, yes, this makes sense. But chemically, because now the question is, if we have a relationship from A to B and a relationship from B to C, can this relationship happen? Can we have this relationship, right? Now, as a molecule, can we have something like this? Maybe looking at some energies and reactions that are happening in during reactions. Can this happen? That was the question. Can this happen? Because we have a relationship from A to B, from B to C. Can this happen? So that was sort of a question mark to say there's some consultation needs to happen here in order to see whether this can happen.
I think we still haven't answered Professor Goswami's question, which was, how do we choose the direction? The answer we came up with that. Do you want to answer?
I think.
How do we choose, the question, this is a specific question, how do we choose which direction should the connection have? And we didn't answer that question.
In terms of molecules. Was it in terms of molecules or here?
No direction.
Yes, in terms of here, there's no direction, but the answer or the sketch of the answer that we gave, okay, you can go first. Okay, the idea that we came up with was in terms of energy and valencies, these atoms are different and they have different valencies and different energies, right? And to give direction between carbon and oxygen, if these two were to separate, the electrons in the edge would rather go to the oxygen than the carbon in terms of reactions. The electrons that are here on the bond would rather go to oxygen and to leave oxygen negative than to go to carbon. So that's where we're thinking the direction could be towards there, because will be an anion, this will be a cation. So this will rather take the electrons pull the electrons from this one to this one. I'm not sure if I answered
Yeah,
the question.
that's exactly what I was thinking of. So the morphisms are the electrons. Electrons are actually morphisms.
Points of electrons.
No, individual electrons are morphisms, are the arrows. And if an electron is shared by two, and we noted that the same electron cannot be shared by three atoms. If an electron is shared, it's always shared by two atoms. So it's an arrow. But why the direction? As he explained, if they were to separate, where would electron stay? Where would electron stick? That gives a direction. If it would stick on the right side, it means direction goes from left to right. The direction shows what would happen to an electron if the atoms were to separate. That was the answer. That's the answer we gave to the direction question.
Question is, this is already a stable compound.
If they were to separate, so for any two atoms that share a common electron,
yes.
Question is, what happens to that electron if we force to separate them?
So your direction does not make sense for any stable compound. It only makes sense when it's on the reaction process.
Imagine the solar system. There's the sun and there's the earth. Now it's stable, right? So none of the two is leaning towards the other one. But the sun is bigger, it has more mass. So you place an object in the middle between the two. This object will likely go towards the sun.
So that's what I'm saying. This concept of direction only makes sense when your reaction is actually taking place, not after reaction. Because after reaction,
It's just that the sun having more mass has more ability to attract. We need a belief.
The gravitation.
The gravitational vector field is
So you are taking the valency as your direction. More valency, and then the directions will be according to. So for that, you don't need reaction.
If you, I'm using the reaction to explain the direction. So the direction determine what would happen if they were to separate.
You don't need connection. Oh yeah, you don't need direction. You can work on any. I mean, forget about organic chemistry. Even in any compound you work. Take nitric acid, HNO3. Okay, so when any compound forms, it should be 0 in total. So oxygen has 2 times 3 minus 6. Okay, hydrogen has 2 plus 2, and nitrogen has plus 4.
Can you please draw the diagram for that?
What do you mean by diagram?
The diagram of the molecule.
Prof, the way the molecule. Let me have an idea for the let's look at this. My own understanding, let's look at sodium chloride.
Yes.
Sodium is that atomic number is 17. No, sorry, 11. Is it?
Yes.
And Cl is 17. So there is something we call electronic configuration. The way they write this is 1s2.
Right.
2p, 6, 3s1.
Now it makes sense.
This is This is 10. 3s 2. Let's only take 2.
Yes.
And 3p1.
P should be
This is 4 and
5.
2 is 7.
That should be 5.
Is it?
Should be 5 here.
This is 5. But I'll be using this to draw it. This is 281 and this is 287. So the first electron 1, 2, 3, 4, 5, 6, 7, 8. And this is 6. I see the aim here is to form an octet structure. So you can see that this is 1, 2 here. This is fine. This is 8. But now this one has 1. It's ready to lose this one to maintain that structure. But we have 17, which is this. 2. This is 287. This is ready to take one to form up this ring. So sodium can easily release this electron to chlorine. So that this we have a new shape, which is this. And this one we have another shape. That is, we call it electrovalent bond. That is the transfer of electrons from one to the other, just to form their normal octet structure. So now, as this is losing, this is Na, because it's losing one electron. And this one is taking, that is Cl minus.
Cl minus.
So they form a sodium chloride. So from what I'm seeing there's a direction now. At least this electron is going here to get their own structure. So there's a transfer of one electron, so which can play a particular role in a category 3.
So can I ask a question? So that electron that wants to move there, it is still part of the first atom as well, right? Because it will be shared electron or not?
No, it's going here. Now you can see now the new shape.
But if it's a molecule, NaCl, if that's one molecule, shouldn't they be sharing an electron in order for them to be a molecule?
No, but they do this chemical bonding, which is called electron bonding.
This electronic bond, ionic bond.
Kind of bond.
Okay.
It's a bond.
This bond is very different than.
I see.
Okay. From what they were trying to explain. So I thought of this. I said, this is ready to lose this electron to form an octet structure, which is now fine. While this is ready to take one. So we can see there is this transfer of one electron to this. Because in some cases, atom cannot give out more than 1, 2. Because if I know that I need 2, or let's say I need 2 to form my own octet structure, another person has need 3. There is a way we do it. I can't give a lot of electrons out. That's why we have all this covalent, we have they have, in a case they share. We have cases where they share electrons.
Yeah, that's the cases we were discussing.
Yes, we have cases whereby it's okay, let's share so that we can form that octet structure. I have 2, you have to, let me give you this, let me give you so that we can form. So there are cases like that.
So in the case when they share,
yes.
So first of all, in our category, morphisms are the electrons. The way what we discussed before. Electrons are represented by arrows. But now, how do we choose the direction of an electron? If it's an electron that's inside an atom, not shared, right? It would be an arrow in a loop. If there are 2 atoms sharing 1 electron, then the tendency of this electron to stick with the atom if they were to separate, one of them would win over, right? That is the direction. So if this electron, which is shared by two atoms, we view it as an arrow from here to there, if when they were to separate, this electron would have stuck to the other one.
Abass, I don't understand sharing of an electron by two atoms.
They can share electrons. They have
That's how molecules are formed. That's what these edges represent.
They can share electrons. We have native bonding. They share electrons. I would look for an example maybe for they also share electrons. I think in a case where let me look at an element that can share electrons.
Well, it's on the picture.
But they share it. I know that. It's possible.
Chemical bonding,
Yes, it's very
H2O, for example.
Yes.
They're sharing two electrons. Am I wrong?
There's covalent.
No, not two. Sorry, it's two H's and then O, but they're sharing electrons. That's how they're bonded. That's how molecules are formed.
Yeah, you can share it. In that case, I think they have to come together now. So I think like something like this now. This is this electron, so they have to share this.
The one that shares electron, I think, is metallic bonding.
I don't remember that, but they can share. Because okay, I want to form and you want to form. Let's share this thing. So
when we draw these molecular diagrams, isn't that about sharing electrons?
Yes, it is.
Yeah.
Just sharing that.
they share electrons, I remember.
You're not convinced.
Yes.
From the it really shows the weaker point of graph.
Yes. That's why actually we're saying that category is more information than graphs. Because with graph theory, it only deals with and it even captures the vertices and the edges. Also, if the edges are weighted, then the weight of the edge. The only information the vertex can reveal is the what do you call the degree of the vertex. But now when we're looking at that structure of towns, right? The cost structure. When you factor in the fact that you might have to delay due to layover and other things, the graph theory doesn't touch that. It only captures on Pretoria how many bonds are going into Pretoria. So we have 3. That's the information that can be revealed. But in the terms of the accommodation and the other ones, that category can source information out of there. It doesn't capture that.
If I want
so it has to be limited.
Just to add one more detail to what you're saying. If I want to fly from here to Durban, I'm going back Pretoria, right? It's not just adding the cost of flying to Pretoria and then from Pretoria to Durban, because those two flights, if they are not scheduled correctly, I might have to stay a few days in Pretoria. So there is an additional cost. So this specific morphism, which is the specific flight from Cape Town to Pretoria with a specific amount of money that I need to pay for it. Then the other specific flight from Pretoria to Durban, when they compose, in the end, the weighting of the composite is not going to be just the sum of these two money, because I might have to stay in Pretoria, so that also has to be added. So it's not, you cannot extract the information just from the weighted graph. You need to know exactly how things compose.
Okay. Which means if this group can be able to get the molecular category right, it will be a more general structure than any other, even your graph structure.
Yes.
That is because sounds interesting, but are you also considering the time?
Yes.
The category considers the time, but the graph doesn't consider the time.
It's actually because I'm looking at the case whereby I'm using a flight. Sometimes because I need a cheaper flight, what I do is I won't book a flight going direct. I'm going to Italy now. I'll have to go through Dubai because I want a cheaper. But my layover is 10 hours.
Exactly.
I have to sit down. Because at the end of the day, what we are after is we want to minimize the cost. And also, we also want to
Minimize the time. Yeah.
So as we do it, so if we can solve those two problems, then this is a.
That's exactly what we were discussing.
Nice.
It's exactly what we were discussing. The problem that you mentioned is exactly what we were discussing.
Yeah, actually, there were just that they were not
Yes,
there.
they are both.
There were some points that were factors. Time was part of the factors.
It's one of you mentioned.
Yeah.
I thought of it. If you can do those two things, then it's a nice project.
Why don't we attach weight also on vertices as the time factor?
It's there actually.
Weight on
It still
weight on
doesn't
vertices.
help because if you attach weight to the vertex, it doesn't help because how much I need to stay to Pretoria from one flight to the other depends on these two flights. It's not a universal weight that Pretoria can remember.
Yeah, that's true.
Yeah.
So maybe we can attach an age which each vertex, depending on which age you are joining. And
That's what a category is. It tells you how the two edges can combine to a third edge. All right.
Question was asked, no one said, yes, there are hidden categories in graph theory.
Yeah.
There are two answers. One is cost category and the other is molecular category. Shall we move on or is there more to discuss?
We are done with the chemistry, but we back here. Okay, so this was I would say this is right. This is Cape, this is Devon, and this is Pretoria. Right? So we are having look for this, and then we are having 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 this. Right? So this is 2. This was 3. This was 3.
Just an estimate.
This is 3. And then I think there was 4 here, if I'm not mistaken. I can't remember what was here.
5.
Yeah, let's just say this. Okay, so this is in terms of graph theory, right? Information that we can get from here. So these are the matrices. Information that we can get from here is especially with directed graphs. So we are looking at the connections. Because here there's no edge that is coming here. The degree of this will not have a degree in directed graph. The edge is not coming here, it's going to this one, is going out. So the degree here would be 2. And the degree here would be 1, the degree here would be 1. But the degrees only shows how many edges are getting into that vertex. So the issue of time, the issue of layover and other things cannot be, as far as I know, cannot be taken out of the information cannot be taken out of this as a graph. But now when we bring in category theory, those other things, information can be sourced out of this, as far as I understand. I'm not sure if I answer your question of why can't we look at time when we're looking at graph? Why can't we look at other things?
Okay, my point is, we don't use graph theory properly. There's a problem of graph theory.
What?
Well, we can fix this by using graph theory itself.
We can't.
You can.
The aspect we are capturing cannot be captured any other way.
No, I'm saying forget about graph category theory. You can actually attach extra age, which you look after of the time over you stay.
It won't. Because time over depends on the in-flight and the out-flight.
Yes, exactly. That's what I'm saying. If you have a flight from up to down and this, according to these two, you attach 1 extra age.
Where?
From where to where?
At B. Between B. And then you count that thing, it has its own weight. That age. Like
That
this.
depends on the
Exactly, that
in-flight and the out-flight.
Yes, yes, for each of them, I'm saying that you attach another thing. For each in and out.
But that data will be equivalent data to giving a category structure.
But no, okay, Prof. Here's my question. Okay, from here to here, we are saying we are flying to there, right?
Yeah.
So if we have this.
Yeah. That
do we still consider this as flying?
No,
Okay.
that I'm attaching an age which corresponds to the waiting time for this flight and that flight. So that age is not flying, that age is for the waiting time.
But now our ages are different.
Waiting time depends, Amartya, when you arrive and when you want to leave.
Yeah.
Our ages are different.
It also depends on your actual airline, because one airline might offer you hotel stay, the other might not. So the cost also depends on that.
And how this categorically we solve this problem?
So we want to calculate what is the total cost from flying from B to D via P.
Yes.
Right?
Yes.
And it depends on the specific flight I take from B to P and the specific flight I take from P to D, together with what's going to happen inside P when I take these two specific flights. So that's how these two morphisms from B to P and P to D will give me morphisms from B to D.
You encode everything in the composition. When you want to compose the first slide with the second slide, you need to add the two durations of flights. You also need to add the time between when you arrive at one place and when you start that. This goes inside the composition. And maybe you are right that for waiting time you could consider first edges, but for other kind of stuff you might not be able. For example, let's say that an airline offers you a discounted price if you book the two connections together. Then this isn't an edge, like a loop in the middle of the really that when you buy the two flights together, the airline gives you a discount, so you encode this in the composition of the category. But you couldn't do it as an extra edge.
But now, you want the graph theory to cater to include everything, not a category to be incorporated and cater also other costs. So he wants the graph theory to do everything.
But disciplines do not exist, structures exist. There is a structure of a graph, and you want to add more structure to graph so that it can include more information. And we've come up how to do that. The additional structure you need just is exactly the structure of a category, which is also an additional structure on a graph. The category is just a name. It's a graph with extra information.
Okay, that is what is key for.
Yes.
We found it.
Okay.
And we presented it here.
Okay, we're done.
Maybe from the picture, what other factors were we considering?
Everything, what you also mentioned, the time, connection
time.
The type of transportation as well, that was part of that.
So I have this thing that you said you're having problem.
I was between the two. I don't know.
Sorry, ages.
Yeah.
I'm thinking of, if you look at this, our state of matter, solid, liquid gas, that yes.
Yes, yes.
Solid liquid gas and solid can go to gas without particles. Yes. Obviously, what is from liquid to gas? Is what? I know it happens because I see that process. So I don't know anything you can bring in that can work. What can happen?
Yeah.
Right, it's an interesting idea. That's why I'm laughing.
Composition is a very fundamental ingredient of how it works. And category theory is basically the study of composition. like the solid to method solid to liquid gas. That's position when you combine the two, they get directly from solid to gas. That's the example of composition.
Because I had him say they're having problems.
It was a specific case where for us now morphisms were individual electrons. And amorphous from A to B was an electron that's shared from between A and B. Another is shared between B and C, but now there is no electron shared from A and C, but there is some force by which A and C are kind of closer to together because of the B.
But also I got
Okay, so we actually yeah, the second discussion was quite long because we wanted to convince some more. So we now have half an hour left, right?
Yeah.
Yes, thank you. So we now have half an hour, and I'd like to propose that we go back to the list of items we made at some point, and maybe look at the action items and specifically talk about the one that was in relation to students. Okay. So, on the question of integration of everyone who is at the workshop in the focus area, I think everybody who was at the workshop kind of you can see what the focus of the focus area is. Then you can see how you can integrate in that. But now let's talk about specific plans for students. So I'm going to ask a very specific question. Well, first of all, just a question. So if we manage to find funding for all the students who are here to continue their studies with your co-supervision from your university, to continue studies, let's say at Stellenbosch University, will you let them go?
I will. Is their choice. As an HOD, I will definitely.
Okay. Kishan is now moving to University of Johannesburg. So that's, and I think University of Johannesburg also has funding for South African students, right? So I would like to make a very specific proposal. Stellenbosch University, University of Johannesburg. Maybe the other universities also, like Rhodes, where Eric is. We need to ask him how easy it is to get scholarship there. But what I'd like to do is a commitment that we will try all we can to get scholarships at Stellenbosch University and University of Johannesburg. Is it something you'd like to do? To move, let's say, to come to Stellenbosch?
Yeah.
Yes. Is that a yes from everyone? You can be very honest, so we can also kind of have an idea how many scholarships we're looking for and so on.
Yes.
Is that a yes from everyone?
Yes.
Yes. Yeah.
Okay.
Obvious, yes.
Great. Do you think? Are you happy with that?
Happiness comes from them, right? I mean.
Okay, so it seems like. What do you think, Dr. Abass? Is it a?
I'm in support of the happiness.
Okay. Okay, so.
The other one going to work.
Okay, in that case, we are going to, as soon as this workshop is done, we're going to approach the two universities. I'm going to approach Stellenbosch University, and maybe you could approach University of Johannesburg. And we can, maybe one practical question. So, is it, do you already have like NRF bursaries?
I don't get the question.
Bursaries from National Research Foundation, do you have them? Currently, you have those bursaries. Why don't you have it? Okay. So at Stellenbosch University, one rule I know we have is that in order for you to get a bursary from the university, you should have a proof that you've applied to NRF and you didn't get it. That is the rule we'll have to see how to overcome, because NRF deadlines is finished already. Like those who are honor students now, do you have bursary to do masters at SMU from NRF? Have you applied in the middle of the year for next year?
Yes.
Have you received the outcome?
No.
Okay. So if you receive a positive outcome, what I do know is it is possible to transfer. So then we satisfy Stellenbosch University requirement, because if you've already applied and you receive it, we will transfer. If you don't receive it, we will tell Stellenbosch University, okay, here's a proof that we've applied and we didn't get it. And so then they can hopefully give us bursary from the university.
But their response usually takes time, isn't it?
NRF, I think, usually responds by the end of the year.
Yes.
Yeah, because students have to start studying next year. So, but in the meantime, those who want to register as Stellenbosch, in the meantime, you can start completing the registration. Application, I mean, sorry, not registration, application, yeah. And no, in the application, you say that I'm an honor student or I'm a master's student, I'm completing at this time, and then you don't have to already have degree, I think, for provisional acceptance. Yeah, yeah. And what about University of Johannesburg? Does UJ also require that you need to have applied for NRF before you can continue? Or you can get bursary?
I'm not sure. I receive funding from NRF. So I'm not sure about rules about other.
Now, the other thing is that, so if you're all going to be kind of registering at a different university, let's say at Stellenbosch University, then the next question is, well, first of all, what topics you want to work on, and you have complete freedom. We're not going to restrict you on that. Of course, we prefer that the topics you choose will be the ones that are aligned in the focus area. But even if it's not, that's fine as well. So
fine as well. It depends on the availability of the sport.
No, we will find supervisors. Yeah, that's actually true. It does depend on the availability of supervisors. Sure. So that is true. It does depend on the availability of the supervisors. Let's say you want to do your project in mathematical structure of forest. Actually, I have a master's student who is doing masters in that area. Now we need somebody from forestry. Maybe at Stellenbosch University, nobody's available from forestry, right? Then they will struggle. But the mathematics side of things, well, first of all, I'm available in any topic. Of course, if it's a topic where I'm not an expert, we would need a co-supervisor. And the co-supervisor doesn't have to be from Stellenbosch, it could be from anywhere. So I'm available in any topic. I think also postdocs are able to also co-supervise, and I think Luca and Elena are also available for quite a broad range of topics. Is it any topic or is it category theory related? Okay. Okay. Any.
We're not that strong yet.
And any topic where differential equations is not the main focus, Luca and Elena are also available.
Categories, metric spaces, algebra.
Any topic that's aligned with the focus area, and any structural topic, they're available as well. So it will be a lot of support from that point of view. And then also, I think it will be very nice, Professor Aphane, if there could be co-supervisors from SMU. So we can keep in contact because we are all busy, and maybe through the students we can collaborate together as well. What do you think of that? Or you don't want that because you have a lot of students to supervise at SMU as well.
The problem is we rely too much on research associates. They are not even on So if the research associate, their contract is not renewed.
All I want to say is that if somebody wants to be a co-supervisor, they're most welcome. Yeah, yes. Well, okay, sure. Okay, great. So that's sorted, and that's actually very exciting and excellent news. So I think it deserves a clap. Great. Now, the other questions, the other action items are here. Which of these also require input from students? Maybe the community engagement one? So here is a concrete question to start off. You're very busy with your studies, right? Outside of your studies, what do? Do you have hobbies? How do you spend time? Do you do part-time work maybe? Yes.
I personally do athletics.
Athletics, fantastic.
I play soccer.
Soccer.
I do part-time work.
Part-time work.
During the week.
Does it help you financially?
Yeah.
Because you said you didn't get a bursary, so probably that part-time work is helpful for you. Yeah. Can I ask what kind of work is it?
Something on my tutor.
Tutor, okay.
The tutor, like a private tutor.
Tutor, fantastic.
And then during the weekend, I work as a waitress.
Okay. Okay. No way. Students at Stellenbosch University, if you go to restaurants here in town, you will find all of them are students.
Students are actually waitresses. All students.
Yeah. And you also wanted to say something?
No, I just my hobby is I train. That's what I do.
Sorry?
I train.
Trade.
Yeah.
Train.
Bodybuilding.
Ah.
Not really, not
Nice.
bodybuilding.
So
Building.
oh, you look like a fighter from a movie.
Yeah, I do martial arts.
I got trailing on the mountain.
So, Professor Aphane, if we can get a sponsor to give us funding so we can pay the students, our postgraduate students, to go and interact with the kids, that will be your part-time work. Inspiring younger kids for mathematics, that will be part-time work. And that could also maybe support the bursary as well. Would you be interested in such a part-time work?
Yeah.
Yes.
Okay. So we make a team. Like as soon as the workshop is finished, right? We make a team. Us who are here, we make a team for this outreach activity. We'll have a list of us who is on the team. We will go to sponsors. We will tell them, give us a lot of money because we want to make a big impact. And then we can use this money to pay you for your time when you go out to schools, you interact with the kids, and maybe actually you interact with the kids that are in that mathematics and physics and technology school that's not far from SMU, so that maybe when they get to apply to study at university, maybe they can move out And for example, once again, come to Stellenbosch University, because you saw that we don't really have mathematics students here. South African mathematics students, we struggle. Do you know that every year, in the third year, those who major in, let's say, pure mathematics, 3. Yeah. Every year we have around 3 students who major in pure mathematics. Can you imagine that? That's how we struggle. We have 20 honors courses. 15 of them are elective, and 3 students that pick the elective courses. Oftentimes, it's 1 student picked 1 course. All the time that this lecturer puts in teaching this elective course to the 1 student is spent just for that 1 student. And this is part of our workload as well. It's just the lack of it's a real problem at Stellenbosch University and many other places as well. How many honors students do you have at University of Johannesburg? Let's say in pure mathematics.
8.
That's very good. That's a very good number.
But in third year, we have 106.
That's fantastic. What happened from 106 to 8?
They choose between 2 and the other M. Mathematics and money, they choose money.
In terms of community engagement to sponsors, if you also want some evidence and a report of the ones we've been doing, we have a collection of already we are doing a lot, just that we cannot sustain it. So if there is a sponsor, that means we have a track of what we've been doing. We can provide you with the videos, which is to second hand.
I think they have a quarter one.
They are not just one, we do have not only for this year or for last year, even from that is 2021. We have got a report, a serious track record of engagement and community engagement. So we can provide that information.
That's fantastic. That's fantastic. It'll definitely be useful.
Maybe when yes. We want to now understand
Yeah. 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 Absolutely. I think I also want to ask about the time frame. So the honor students are going to be starting masters next year, and we already discussed how that will work. What about the master students here? When are you finishing, and when are you going to be moving to PhD level?
3 masters.
No, just the 2.
When did you start your masters? This year. So are you going to be finishing at the end of next year, or is it 1 year masters or 2 year masters? Okay. So is the plan that they come to Stellenbosch for PhD? Is that the plan?
That's not the.
Or is the plan to already?
If they decided to come from, you will sign.
Okay, so there is a possibility for them to transfer.
Yes.
Okay. You have a very kind head of department. Is that something you might want to consider? One next year. Yeah, transfer. You can build on what you already done. We don't throw that away. We build on it. You will continue working on the metric structures, right?
Yeah, because my own thought. So first, the transition by people that have been doing from living what I'm doing about it. Let it survive.
Don't worry, I'm giving them.
Maybe to doing all those things. You need to put them what should you do? Let us survive. This boy is coming from PhD. what do you think? This is what we are. This is what we are. Supervisor might still be there, picture, and maybe you are a co-supervisor is from this, or professor comes home supervisor. As long as the student is ready, then we now say, okay, this is what we are. Then the 6 students design a project for the student. Can we continue in this direction? Once the student is ready, I think it's fine, because sometimes something you have been doing for years, someone will just come say, no, let's go in this direction. They might tell you they are right, but at the end of the day, they will run.
No, yeah, I completely agree. So, yeah.
Because the first question was, if they want to come this side, can you call supervisor?
Yeah.
I get that.
And the idea is not to change the direction.
Just for this.
Yeah, just for these two, yeah. So they will continue, the supervisors from SMU, whatever they plan for them, that's what they will be doing. They will not change the trajectory. But it might be a good idea for them to transfer, because then they can get used to also new environment, if they then want to afterwards continue with PhD. But as long as we're not taking away anything from SMU, as long as we make sure. Okay, great. About the so another place where the interaction with the students now is useful is crash courses. So if all of you or some of you are, let's say, moving to Stellenbosch next year, these crash courses are probably not important for you specifically right now, but or not, I don't know. So what do we do about this crash courses thing? Because as I said, NITEX has the structure of offering online courses, and we could have somebody offering those courses, let's say from NITEX room, or maybe coming to SMU, or maybe somebody from SMU maybe would like to actually, maybe you could offer a course for our students, right? So do we want to set up all of these already now, or do we kind of park it a little bit and then we come back to that a bit later after we sort out the other things?
That one, I was referring to those who will be interested in this site.
Mhm.
And also from that side, in future, when we have put things in, then we can say for our masters, then we'll have 2 weeks crash course, and they attend that and get one. So I was speaking for both sides. Say, when you come into a new activity to if they can just have that period to build the literature and then kickstart with the
So this is okay. So you see this as a way of kind of helping with the transition. Is that what you're saying? Okay. What I'm asking, I think, is imagine we've set up a kind of framework which really allows every year for us to have funding for 10 students, for example, in our focus area to do this transition. Will we really need crash courses for them? Because they can first come and then here they can. So do we really need to prepare them for the transition in terms of the coursework? I'm not sure. Maybe crash courses could be more useful if students want to decide if they want to come or not, and then maybe that could be. But if it's about decision, should it be a course or maybe more interactive thing like what we're doing now? Unless
that one,
yeah.
we can click it and we see as soon as they are this side and realize that we can do some research and then.
No, as I said, there are many courses we give in the department, honors courses. So when we feel that a master's student needs to catch up on something, we usually recommend them take the honors course that is being offered. Yeah. Plus, there are these also online NITEX courses which they can take. Yeah, I think so then this evening during dinner, the academics will give the students and the academics will get together. We can kind of discuss more details over dinner. But is there anything else that is relevant to students that we should still touch on?
Madam Prof.
Yes.
You want to read an exam?
Yes.
Prof, my question would be, okay, what if now I'm dealing with graphs? Right?
Graphs.
And then, yes.
Yeah.
And then I'm saying at my master's, maybe I want to go to spaces, metric space, or Banach space, Hibble space. Is that possible this side? Or
Yes. Yes. We have 3 colleagues in functional analysis, those who study spaces. So we can get them to co-supervise. We have but we also have colleagues from the focus area like Professor Bruce Watson and Wenchi Kuo. They're also functional analysts. So maybe first we will try to approach them, but of course it's nice also to have somebody that's local, that's an expert in the structures you want to study. Yes?
So since you mentioned that the courses will not be accepted, so how will we get our certification for those crash courses?
The crash courses that we currently do, well, NITEX does offer some kind of diploma that you attended it, but it doesn't really mean much, right? The courses that we do is not for certification, it's more for your own growth, known benefit. That's how we do the postgraduate courses. But of course, if you take a course at the university that's part of the university offering, then you will get a letter from the university saying that you completed this course and you got this mark.
So for the community engagement, there's an aim from this year, for the end of this year.
No, we will this year, we will try to get sponsors in. It will be a bit slow process. Hopefully we will have some funding from next year.
And we were mentioning us being there.
Yeah.
And us being here, I don't know.
No, I know, but that's a good point. But you would want to visit home as well, right? Yeah, so maybe when you're visiting home in that period, and also the funds for the trip home can be funded from this community engagement thing. But also here, one can also engage with communities. We have, we have communities which are a bit isolated from the university. They don't come to the university even though they live here. There's also the opportunity to engage there.
So it could be wherever you are.
Yeah, it could be wherever you are. Then there is also this chief from Venda that I spoke with that they want our support there as well. So you will be flown if the school is far, you will be flown to that school, stay there for a few days. Everything will be covered. That's the plan. Anything else that you think we should touch on? Very good. Well, let's maybe then quickly chat about plans for tomorrow. So tomorrow we are not going to do anything too serious. We're just going to have fun. Not that we didn't have fun up to now, but so the suggestion for tomorrow is to for the morning, to be free morning. If you want to explore the town, maybe you want to get some souvenirs, you can do it on your own. Just don't go too far out of the town. So not Cape Town, Stellenbosch. Then we meet here at lunch. We use our vouchers. We finish our vouchers to have lunch. And we also buy some extra things so that we can go on an excursion between lunch and dinner. And I hope that we will have enough number of cars. I made a deal with Luca about that.
I think you calculated 7 things. Professor Goswami calculated 7. You calculated 7 things. Sorry? The population. 17.
17.
Yes,
We
sorry.
need 4 cars.
He said 17, so 4 cars.
So 17 is 13 plus 4.
4, we can't take.
But if Abdul, the coming, we are 19. But in any case, we need 4 cars.
Yeah. So I think Kishan is also available. But Kishan's car, my wife's car, without my wife, so she will lend the car. And Elena and Luca's car, that's 3. We need 1 more. Do we need 1 more? How many?
We are 17.
Are you taking into account the driver is also part of the count?
Yes, we counted the drivers. We are 13.
To where?
Are we all going?
Yeah. Is there anybody who doesn't want to go to excursion? Excursion. You sure? Okay.
No.
Isn't it 5 people per car?
Yeah, 5 times speed. We are 60.
Ah. So we really need Abdul.
Or we can.
We need to convince someone else. We can. Hopefully, yeah. Yes. With the promise that we will also invite them for the dinner.
Yeah, you have to give something.
Yeah. For dinner, we have 20 spots.
13. Dinner and there. No, 14, 15, 16, 17, up to 18, Ali 19 already. So
Now, the way the dinner works is that the university gives certain amount of money per person, and usually it's quite a lot.
Yeah, it's quite a
We
lot.
can get 1 more.
So if it's 1 more, it should be fine.
Using the optimization problem, the basic approach both Ram and Peter, because it's one driver for the school. Understand what I'm saying?
Yeah. Yeah.
And it is easy.
What about Michael?
But if you can.
We're talking about this. Did you realize that we're actually talking about all of this online? It's being recorded.
Did you say something bad?
No, we didn't. No, we didn't.
He's still into Vietnam.
Thank you so much, Johnny, for engaging with us. Thank you very much for being with us. We will definitely reach out to you. Let me just type.
Thank you very much, Prof. I wish I was there in Cape Town.
What do you do, Johnny? Are you a student? Are you what do you do?
No.
Yeah, I've learned a lot. I'm still learning, and I've got a lot of questions. Thank you.
What are you learning, Johnny?
In terms of mathematics now site by.
Okay. So please send the email. Let me also give you my phone number. I'm typing in the chat my phone number as well. And please send me a message. Thank you very much. Otherwise, I'm going to now close the Zoom meeting. Hope to see you some point soon.
Let's start for joining.
Sorry about that, my internet cut.
No problem. Did you hear that we clapped for you?
Oh, you clap for, I didn't hear, my internet just cut. Because during that time when the second question was, I was asked, I was just thinking on my mind to say, how do I approach this? Will it be correct to put sort of an infrastructure of taking it from the group theory, and then from there, and then it makes some assumptions like that a portion of the cost, Cape Town, Durban, and then will it be correct to include maybe variables like list action, and then and also now because if
Tomorrow for lunch.
oh, thank you very much. Thank you very much.
Thank you. Thank you.
Thank you.
Bye.
Bye.